You are in the right place. I hope you're going to tell some friends to join us over the morning. Hello and welcome. Bonjour, bienvenue. I'm Thomas Desson. I'm glad to be your host this morning. Indeed, it's going to be a great morning. Amongst all the decision makers, we're all gathered to link this entire value chain. Everybody in the field over the next and last few days at JEC World is concerned, from big companies to the most innovative startups. We're going to talk about novelties, new trends, artificial intelligence, who are going to be the winners, the losers. Obviously, AI is a train that's rolling at a frenzy rate right now. Do we want to catch it or not? Those are the questions. Legacy, sustainability are two major goals from Paris 2024, as well as two important topics being talked about in the alleys of the JEC world I could hear lately. It's a great momentum for the City of Lights right now as well. With Paris 2024, JEC World is going to bring some legs to those events, the Olympic Games, obviously, and the Paralympic Games down in September. Our goal today is to unveil two major objectives, let you know further about the different composites, utilities, and benefits. And obviously, with this sports summit, our focus is to show this is the industry, sports obviously, that serves and offers the most innovation, as long as you have obviously generous sponsors. Money talks as always. I'd like to thank the expertise of Global Sports Week, GSW, that came up with this sports summit. Together we're going to highlight with some of the athletes and sports leaders that I'm going to welcome on stage within a few minutes, how we can all benefit from this research and development. This is the whys. Let's get into the how with a great program this morning that I want to unveil. Well, there it is. 4 different sessions to pan out all these mind-blowing topics within about 10 minutes with high-profile athletes for gearing up for 2024 will understand how much the materials are at the core of the performance. When I rehearsed with them, I asked them, how much do you think a composite could get you to earn a medal? Well, some said 20, 30%, so it's a huge difference. Some others don't think it has so much weight on it. 10:30, our second session, thanks to Global Sports Week. We've discovered this past June at Vivatech that we've underlined how much sports and technologies are really at the peak of innovation and serve other industries afterwards. Tim Holland will be your host. They'll be relating with different company owners in the sports field, and they'll let us know how they managed to bring great improvements and innovation that serves many others afterwards. The third session, right around 11:15, we'll have the honor to be back on stage to focus on the Paralympic sports and their equipment. And right around noon, I want to say sky is the limit. We'll be surfing, we'll be gliding. It's going to be the feeling of flying. That's our last round table. We'll feature with water sports, and now obviously a device that's very much utilized and served with foils. Let's get started with our opening. As you understand, cutting edge innovation today reveals technology unveiled. Let me welcome on stage Mr. Cédric Roussel, Deputy in charge of the sports economy, and I discovered, most importantly, playing on the wing with the Parliament's rugby team here in France. Cédric Roussel, good morning. Cédric, I understand you'll make your keynote in French. The stage is yours.
Thank you. Good morning. Mesdames et messieurs, chers amis, passionnés d'innovation, d'industrie et de sport. Le ministre délégué à l'Industrie et à l'Énergie, Roland Lescure, qui n'a malheureusement pas pu être présent aujourd'hui, a néanmoins tenu à ce que je puisse, en tant que délégué ministériel à l'économie du sport, remercier en son nom les organisateurs de cet événement pour leur invitation et aussi vous faire passer un certain nombre de messages. Depuis 1970, le JEC World s'impose comme un phare de l'industrie des matériaux composites, transformant Paris en capitale mondiale de cette innovation. 49 pays sont représentés au sein de 27 pavillons internationaux. Cette année, plus de 1300 exposants et 43 000 visiteurs professionnels participe à ce festival des composites, mettant en lumière donc des défis de la durabilité et les solutions pour un avenir plus léger, plus intelligent et plus durable. L'industrie des composites incarne l'innovation à chaque étape de sa chaîne de valeur, des résines et des fibres de nouvelle génération aux procédés de fabrication robotisés. Cette industrie est présente dans presque tous les secteurs, de l'aéronautique à l'énergie renouvelable, en passant par le sport, ici mis en lumière avec ce premier Sports Summit au sein du JEC. En association avec Global Sport Week, à l'initiative du pavillon sport de Viva Technologies en 2023, ce Sport Summit met en valeur l'importance des matériaux composites dans le monde du sport et de la performance sportive en cette année de Jeux olympiques et paralympiques de Paris 2024. Le ministre Roland Lescure exprime ici sa gratitude envers les athlètes engagés dans la promotion de l'inclusion, ainsi qu'envers les ingénieurs et les experts de l'industrie qui utilisent les composites pour les disciplines paralympiques. Grâce aux composites, ces équipements ne sont pas seulement légers et résistants, mais ils sont aussi conçus pour s'adapter parfaitement aux besoins spécifiques de chaque athlète, améliorant ainsi leur performance et leur confort. Et que dire des innovations dans le nautisme? Les matériaux composites ont permis de concevoir des bateaux plus légers, plus rapides et plus durables, révolutionnant ainsi les courses de voile et faisant tomber tous les records. Sans oublier le cyclisme et les cadres de vélo en fibre de carbone et toutes ces nouvelles disciplines mises à l'honneur cet été pendant nos Jeux de Paris 2024. Je pense au surf, l'escalade et le skateboard. Le gouvernement français, à travers le plan France 2030, investit massivement dans la recherche et le développement et cherche à positionner notre pays comme leader dans les technologies de demain, y compris dans l'industrie des composites. Le salon JEC World et ses initiatives, comme les JEC Startup Booster et les JEC Innovation Awards, sont des catalyseurs de cette ambition. Ils mettent en lumière des innovations qui façonneront l'avenir des composites, mais aussi celui de nos sociétés. Le ministre et moi-même tenions à vous informer à ce sujet de la tenue le 13 mars à partir de 8h30 au sein du ministère de l'Économie et des Finances de nos premières rencontres de l'économie du sport. Une matinée d'échanges rassemblant les acteurs de la filière sport autour d'axes prioritaires comme la transition écologique et l'internationalisation des entreprises dans le contexte des Jeux olympiques et paralympiques de Paris 2024 et où l'industrie du sport sera notamment mise en valeur au travers de son mouvement pour la décarbonation. Pour conclure, je me joins donc au ministre Roland Lescure pour saluer l'engagement de chacun d'entre vous en faveur de l'innovation et du progrès pour un monde infiniment plus sportif. Et nous vous souhaitons un très bon salon. Je vous remercie. Enjoy.
Cédric Houssel, thank you for this official opening. Let's get started for panels of about 30 to 40 minutes. The philosophy behind it is to be a conversation. Please do raise your hand at any point, and so we can have a free-flowing conversation and ask questions to our experts and leaders today, instead of having really a presentation and Q&A afterwards. So feel free to intervene at any point. Please do, really. Here it is. Material at the core, material at the heart of the performance, and you'll figure it out with them. It's more philosophy in order to perform. Let me welcome those 4 experts with us, 2 former athletes and 2 persons specializing in research and development. Jean-Christophe Perrault, Étienne Hubert. Please have a seat, gentlemen. Thomas Dupont with Luc and Corima. And Xavier, Roussin, Bouchard. Let me grab a seat. I gave them an exercise. I said, I want to have a research and development and an athlete next to one another, so it's tricky. Let me grab this seat. It's going to be, well, Etienne, look, you're the black cat. You're right over there. Either or. Good morning, gentlemen. This gentleman here, JC, Jean-Christophe Perrault, this was 16 years ago when you grabbed the silver medal in mountain biking. Time flies.
Yes, maybe.
Yeah, indeed. 46-year-old. He also was the runner-up of the Tour de France back in 2014. People were like, what's going on? The guy is doing mountain biking. And by the age of 37, grabbed the second place at the Tour de France. You'll be celebrating the 10th year anniversary. Yeah, like I said, time flies. Today with the National Agency of Sports, he'll let us know what he's doing right now. Thomas Dupont, maybe you've seen the carbon fiber wheels with Corima. Look is the same enterprise and company. He'll talk about bikes, framing, and pedals as well. We have Xavier with us. Roussin Bouchard is the head of innovation for Rossignol, skiing, and there's a lot to talk about. And this bulky, beautiful, strong gentleman here was a world champion in K4 kayaking by the age of 22, and I do believe you're not done, Etienne.
Good morning.
You're not done, right? Paris 2024 is your ultimate goal.
Yes, 24 will be the last goal for me, and with the Olympics, and so yes, it's the last step of my career.
Wow. How did we rehearse this? I had all these gentlemen for about 15, 20, 30 minutes over the phone, and really quickly I understood it wasn't about performance, it was about human values for each and every one of you. Xavier, for example, when I asked you, what is it that you do? What is your purpose? You said, well, I had to ask myself what was my purpose, and then it was about meeting somebody.
Yeah, exactly. You know, with Rossignol, for example, we developed skis for more than 100 years. So when I arrived in the company, it was difficult for me to know exactly what can I bring technically to the group. But it's a huge adventure, and it's almost technical problems, energy, athletes. You know, we in the team, in the innovation team, we are developing the skis for World Cup athletes. And yeah, it's very motivating to be in such industry.
More than the material, it's the feedback, it's the exchange with the athletes that actually make you guys look for better performance, isn't it? Thomas?
Yes, the relationship with the athletes is very important. For me, it's very important because I can join the technicity and the sportness. For me, it's important. And it's a motivation for me. And what I can bring to the athlete with my technology, it's very important.
You work in R&D. I'm not wearing a hat because I want to be fancy and a picky blinder. I just had research and development in Turkey. It's still in the process, so maybe I can gather from you. JC, Agence Nationale du Sport, National Agency of Sports. Let us know about it. You're kind of like a financial advisor. You try to figure out where to put the money, what makes sense. Is that what it is?
Yeah, we can say that. First of all, athletes are here to perform, and so the agency is here to help them to perform. So we have to figure out what is good for their performance and what it's not, and then we help them to achieve their goal. Yeah.
I remember you gave me an example, for example, Teddy Riner, who's seeking his third gold medal here in Paris 2024. If he wants to do a camp because he has to have big guys in Brazil or in Eastern countries, you may validate this because it has a purpose.
Yeah, exactly. That's what we do.
Do you guys want to talk about what you do? For example, skiing, Xavier is working on prototypes that will come out in the market. When I mean market, for high-profile athletes within 5 to 10 years. But what you were saying is that you guys have long-term objectives, but also very short-term, because at Rossignol, you may make performance adjustments with composites from one week to another.
Yeah, exactly. We work in the headquarters, so in Saint-Jean-de-Moran near Grenoble, and there We have all the R&D team to develop the bindings, the skis, and we have the workshop near to the R&D office, and we can develop and rebuild a ski if some athlete asks. We can build a ski in 1 week. And we have also a program to develop the next innovation steps for more 1, 2, or 3 years.
Etienne Hubert, AFNOR, which means standardization. What does that mean?
Yes, in fact, I'm a sportman in kayak and also working for the AFNOR standardization. And AFNOR standardization, it's my job is to do some rules and some standards in sport. And in sport, there are many standards, as in ski, as in climbing, or maybe in alpinism or mountaineering. So my job is to manage all the project in the sport, and so I need to ask, I need to earn all the partner in sport and in the industry, and all the ministry, because we need to do some rules and good standards for all the good things, and in order to don't do some accident.
Got it.
For example.
We are also following the standardization. It's very important for us because we are using every day new materials and new technologies, and that means that standards have to follow the innovations. We have to understand what the new material will involve in our application.
Whoa. Jean Dujardin is an ambassador for Luke and Corima. Brand pillars. Here we have the DNA, the values of your company. I'll let you go further about those guidelines. Obviously, in FFC cycling, in fees with skiing in a second. But when we were talking about in the intro about the human values, that's kind of what you wanna put out there, Thomas. When we look at your brand pillars.
Yes, we have 3 main pillars. The first one is French spirits. Here we have different pictures with different persons who are very well known. As Jean Dujardin, just an example to explain what we try to follow in our company. So French spirits, the excellence, of course, with the product, the performance, the style, the quality. And also what is important, and I think it's the same in Rossignol, craftsmanship, because all the products that we manufacture are made by hand, of course with small and special machine and tools, but the human people are very important in our industry.
You've worked on those carbon wheels for about 35 years. We remember Corima. We met with Federico Musi thanks to Global Sports Week last year. There's also, as I can see, the bikes, the frames, and the pedals. In link with Cofidis, a Pro Tour team. Also in link with the feminine paracycling team. Quite involved with a few different teams around.
Yes. For the road and time trial, we are working with Cofidis. We are sponsor of this team, professional team. It's very important for us because, of course, it's very important because we are developing our product with them. We work with them very closely to understand what they really need. And we try to adapt the material in order them to get the best material, the best equipment to be as much as possible performant and to win and have success.
We'll talk about sustainability. We'll talk about ethics, but I still want to go through the race for competitiveness with you guys. In sports, we feel like there's a sense of secrecy. Although when I talked with you guys, we realized there's exchanges with other industries, aeronautics, motorcycling. You'll show us some pictures of the wind tunnels. Rossignol does exchange with HEAD, with K2, with others, or we try to keep it our personal garden. How does that work?
It's something quite new in our industry because, as you said, normally speaking, we are competitors, so it's more secrets and patents and for the development. But for sustainability, we think that we need to be all together, all the brands. And so we now, for 1 year, we started a working group with the FESI, Fédération Européenne des Industries du Sport, where all the brands come and all the brands, we are working together. So we are sharing data on the materials. We are sharing how we do our LCA analysis, life cycle analysis. So how we calculate these things to have all the same way and to calculate all the same thing, to have the same number at the end. So yeah, we are now we are moving with all the different brands for winter sport equipment, and it's quite motivating.
You know what's beautiful? This gentleman over here, one of his ultimate goals within the next few years is to create a huge database for French sport where we can all gather all the datas and move forward, isn't it, Jean-Christophe?
Yeah, that's what we are doing at the Agence Nationale du Sport. Yeah, because the next step when you are able to collect data is to make them speak and to find a solution to be better.
Would this be possible? I feel, Etienne, when we've talked, and in France, per se, we have our philosophy. We can have our certainties. And sometimes, compared to Anglo-Saxon countries, we're a little bit lagging behind. When we talk about database, we don't need that. When we talk about mental coaches, I don't need a shrink. I'm doing okay. Why? Is that a French philosophy? Do we need to all get together? Are we a little bit lagging behind? What's your take on that?
About my philosophy in the sport and the material, I think that in fact we have the one manufacturer in Europe. The name is Nelo. Nelo is manufacturer for the boat and for all the stuff like the seat, like the footrest, etc. And all the athletes are paddling with this boat. Nelo, maybe as you can see on the picture, it's a carbon boat, and all the athletes have the same boat. And but we can say, but maybe why you have all the same boat, but it's just like this. But we try to do, and Nelo try to organize and to manage and their project on the boat because he tried to do some new boats for the new performance, and he's doing some evolution, but in fact we have all the same boat. But now we try to work on the rigidity, on the maybe sometimes on the flexibility. Sometimes it depends of the lake because sometimes when there are some waves, you need to have a boat more flexibility. So we try to do some adjustation with Nelo, but it's a little bit difficult to do this.
You've told me when we prepared this panel together, I asked the manufacturer to have my boat very stiff, very hard. Although I didn't understand because I told myself he's doing 500 meters, 1,000 meters, so he just has to go straight. So for me, if you want to be more reactive, it's for turns, but you said it does play a part for what? To have a stiff boat.
Yeah, to have the stiff boat. In fact, if you have the stiff boat, hard boat, it's good when the lake, for example, is very flat. If the lake is, if you can find some waves on the lake, it's better to have maybe a flexible boat because sometimes it's better you can have some different sensation, and so you have to choose. And as we are training maybe about between 20 and 20 hours per week, so we know all the products, and it's the same for the paddle. We know that this, for example, that this paddle is good for me. I have maybe 10 paddle at home.
Can you imagine we're really like
Yeah.
totally beginners? Can you please introduce us a paddle? It's all made of carbon fibers?
Yeah, it's this paddle is welding with holes in carbon, and Gentex, it's a Czech brand. In kayak, we have maybe 2 or 3 brands for paddles. So, and it's all the same. In fact, it's all the same products, the same.
What's amazing here is that it's a frying pan. You could make fajitas in there. Why it's to grab the water. It's very curvy.
Yeah, it's really curvy, and it's for the technique. And this kind of paddle is coming from the 90s. And now all the athletes are paddling with this, and now the sole difference is the size of the blade. And we have also the different type of rigidity for the shaft, and we can also adjust the shaft, so it's easy. It depends. Maybe if you have the front wind, you can for the wind.
Front wind or back wind, you'll adjust the length of the paddle.
Exactly, yes.
So that you don't have to overpower.
You can adjust, because this is good for the plane, of course, it's better. But
I can't get my golf clubs. My wife's a flight attendant, but this is easier.
Yes, it's easier, but after it's you have different type, different centimeters, so you can choose, and it's your feeling. So one day maybe you can paddle with 2 meters and 20 centimeters, and maybe 2 days after you will paddle with 2 and 19 centimeters. So you have to choose, and all the athletes have a good experience, and they know that they are doing, they know that they want, so they have to choose. And maybe the best for choosing is the experience.
I know Thomas wanted to pick up on that because I have so many questions. We see that it's got to be a conversation. We talk about parameters, we talk about composites, and we hear it's about feelings as well. So it's going to be interesting to adjust between something that's very robotic, I guess, and something that's very human and feeling like.
Yes, we have the same kind of concern in our company in looking Corima. With Jean-Christophe, we have been working with the French Federation for 3 years to develop the new bicycle for Olympic Games on track, the wheels and the bicycle. And you're right, the technical point, features, and also the feeling, it's a compromise between these 2 dimensions. So as you can see on the screen, for this bike, you speak about the stiffness, the rigidity, the stiffness, and so this is one.
I really want to thank you because I'm seeing below confidential. So this is actually researches for Paris 2024. This is the bike that's going to win for France?
Yes.
Great.
Correct. So we can adapt the stiffness everywhere on the bike, the steering, the rear of the bike. For the wheels is the same, and we have to adapt the dimension in order the athletes to develop the maximum power as much as possible. The positioning of the athlete on the bike is also very important. So we can adjust exactly the position of the athletes, the ends of the handlebars, the position on the saddle. We have different methods to verify the aerodynamics properties, because in bicycle we have different performance characteristic factors, the aerodynamic, the rolling resistance, and of course the power efficiency.
So where does JC comes into play? Mountain biking, cycling, obviously. This is on track. I remember back in the days in the peloton, people were saying he's very generous on the bike, but he's a man of a few words. Well, we see that athletes that are thinking different are the ones research and development engineers and manufacturers are going to see up to because you guys think outside the box. What do you bring to this?
In my career, I think I made differences because I was thinking out of the box, and I'm also engineer, and the way they are developing equipment, I had the same thinking on my sport, and yeah, so as he said, we have aerodynamic impact, rolling resistance impact, and I was thinking about this on my sport, and so maybe before my opponent, I was able to make adaptation to equipment and yeah, to find the solution to be a little bit better. So in a way, equipment is really interesting for the athlete because it can make difference. And in another hand, when you are doing sport, we should have the same equipment to be able to know who's really the best athlete. So that's the
Xavier,
point.
Thomas, in the end, it's the data, your researches, or the athlete's feeling that does dictate. How do we manage that?
It's both. You know, it's because nobody makes skis with the same movement. Nobody's make the bicycle and pedals like other athletes. So you, in fact, when somebody, for example, Cyprien Sarrazin, asks us to have a ski very stable under the foot, we have in the R&D team to develop some techniques and to build a very specific ski. But if I give this ski to another athlete, he is not going to have the same feeling, and the performance is not going to be the same. So we need data to validate that the theory is good, and that we have made the good choice for the techniques and how we build the skis. But we also need lots of athletes feeling to know if we are in the good way for this specific athlete.
In the right direction.
We try to measure all the parameters, but it's not always easy, you know. By example, we can, on this picture, we can see that we can perform some tests in a wind tunnel. It's easy to measure the aerodynamic performance and efficiency, but the feeling, you're right, is not very easy. And athletes spend a lot of time, by example, on road, on their bike, so the feeling at the end is very important.
It's up to 70 or 80,000 kilometers per season for high-profile athlete. No, not that much.
No, 30,000.
Well, it's still, yeah, you still go around the globe on your bike. You want to talk about the pedal, for example, because we're moving along on this research development. We do have a few images of this pedal has quite a few sensors and
yes, this pedal is very interesting, and it takes parts about the measurement of the
here, Pierre-Louis, look, Pierre-Louis is going to show us
the
in
performance.
close-up. That's going to be great. Look at the camera, Thomas. We're going to actually show it from up close.
So inside is located a power sensor. So it's very important and mandatory now in bicycle to measure the power, the efficiency. We have a sensor in the right and the left pedal, so that means that the athletes can measure the right and the left legs. It can adapt the method of pedaling. And technically, it's a very interesting product because we have composite material, long fiber material for a blade, and plastic injected plastic also for the main core of the pedal. And inside, in the pedal, in the axle, we have several sensors and electronic components, the battery, the antenna, and this equipment communicate with the sports watch or the bicycle computer, and the athlete can manage his effort by following the power.
You mentioned sensors. Sensors makes me think AI, which I mentioned before, and it's kind of like my next chapter. What does the future hold, gentlemen? We said and we sense that sports obviously is usually at the peak of innovation. What does the future hold? Is there still room for improvement? I'm thinking, Xavier, I met Alexis Pinturo last year. To us, normal people, I don't see any difference from a ski to another. It's very hard to perceive from a public side. You guys have still room for improvement?
Yeah, of course. And we at Rossignol, we think that all the technology in the future are going to merge. And we are speaking about the sensors. Now you can introduce data and sensors inside pedals. You can introduce sensors inside fibers and composites. We at Rossignol, we have developed a sensor that you can glue on the top of the ski without any battery, and you generate your energy, and you can follow how the ski is evolving on the slope and how you use it. And we introduce some machine learning. And in 5 turns, you can have you can evaluate your level.
Okay. I'm working for fees. I'm looking on the guidelines. Do you come up with those things without the guidelines and try to push the boundaries, or you have to have the guidelines ahead of the game?
For the fees, for example, we have some rules that you can't have energy on the ski. But here, you don't bring energy on the ski. You generate energy. So we are in line with the rules, and it's R&D. You know, standardization or the federation are giving us some rules, and we have to follow these rules. But we have also to be close to the limit, and yeah.
Sensors on boats, on hulls. I remember, Etienne, you told me the US team is very proactive on sensors, on those feelings of innovation. How so?
About the innovation in canoe kayak, it's about the kayak, the paddle. Yes, of course, the manufacturer try to do the best, but now we have some, like in ski or maybe in cycling, we have some kind of captor you can put behind you. It's a kind of mini computer. And on this, you can have, of course, your speed, but you can have also the balance of your boat, and you can see if you are more on left, more on the right, because it's really important to know when you are competing with some teammates in K2 or in K4, because sometimes you have some kind of left or right stroke, and so it's really, we try to have and to develop this kind of technology. And for the paddle also, the manufacturer try to find a good technology in order to catch the power and to know, because it's canoe kayak. It's a power. We try to do some stroke and some stroke power. So we need to know how we are putting power in the blade. Because it's like this. If I put maybe 30 Newton, and maybe if I put 50, it's a huge difference. So we know, and we have to know this difference and the best for competing. Because the feeling, yes, of course, it's really important. But we have to work with this technology.
Athletes, I asked you the same question a couple days ago. How much composites, how much technology does account in percentage for performance? You did say up to 30% in kayaking. JC has another answer. 2-3 days after you did digest that, you're not sure about it?
After this discussion, maybe more. Yes, maybe
even more?
Maybe 40, 50, because in fact it's difficult to think about it, because yes, for us the most important for the performance is the training, and and all the environment, with the coach, with the family, with the physio, with the training camp, and all the sportsman is on. It's a kind of company. He have his own company. But about the technology, yes, for me it's maybe 40%.
Wow.
Yes.
Okay, but
it's difficult.
I like that. The athlete is the CEO of his company, his enterprise, because you have to pick in different parameters. JC, you told me this with test of a team sprint of pursuit, which is one of the disciplines on track, with the new bike, with new cycling suits. We looked at it and we're close to the world record. So it does change a whole lot.
Yeah, it does. So it's not 30% for us, but as soon as for Olympics, I was working on research subjects, and we were looking the best solution to be stronger. So we have a model. It means we are able with our athletes to know what they will be able to do regarding the time they will do, and in our model we are able to change equipment. So it means we have Corima wheels, and so he did many wheels. So in the model we can put every Corima wheels and see the difference it would be on the result. And so, as you said, with the new bicycle and the skin suit, they are able to win 3 or 4 seconds for 4 minutes effort.
Wow, yeah. You told me a tenth of a second on 250 meters, and so I was doing the math, maybe 4/10 on 1,000 meters. It moves you from 5th place to a podium, or maybe even a nicer medal of a medal.
It's not a good calculation, but it's not the good calculation.
No, it's not the right
because the start doesn't have the same effect. So.
Okay.
But
what I was trying to say, sorry then, 0.4 of a second is probably what, 6th rank difference at the Olympics.
Not so much.
Not so much.
It will make differences, for sure.
Okay, I thought the top 8 was within the same second, but not always so much. It is the case in skiing. Still about the future. Q&A. I see it. Question and answers whenever you feel. If I see a hand being raised, please do participate at any point. Artificial intelligence. You told me, Thomas, we're a little bit reluctant at first. We're getting into it as well. When we talk about 3D printing, this is artificial intelligence, and I guess to build a frame, this is going to help you out quite a bit.
Yes, so we are studying this kind of technology. It will be the future for sure. By example, some some special mechanical software are developed to design structural parts with AI. This is called topological design manufacturing. So this technology is of course associated to the 3D printing, because if you have a spatial shape, it's not already manufactured by classical tools. So 3D printing is very important. As you have seen on the different pictures that we have seen during the conference, we already used the 3D printing for prototypes. It's very practical and useful. And in IA, we also use it in CFD methods and analysis. This is a special method, a numerical method to study the aerodynamics, by example, for the wheels or the bicycle. So in this kind of study, we are using artificial intelligence.
We've been already over 30 minutes together on stage, and I want to take the last few minutes on an important topic, sustainability. And you'll hear that these gentlemen have a very sense of concern about this, but different ways to do it. Etienne, your definition of sustainability is kind of about self-restraint. You've told me I'd rather talk to manufacturers in Portugal than in China, for example.
Yes, about sustainability, it's of course in sports it's difficult to have this because we are using some specific materials, and we are using some planes for training camp and for competing. So it's hard to have some this kind of question, but. For me, yes, I'm happy to work with Nelo, the Nelo company, because he's doing all the boat in Portugal, and all the composite. I don't know where they come from, but for example, they are doing all the stuff, but they are doing the seat, they are doing the seat rest, they are doing the cover, they are doing everything for the boat. So I like this kind of this philosophy, and I like also to see this company. And every year he asked me in the company and to discover how they are doing this. And for the paddle, it's the same. The paddle come from Czech Republic, and it's easy to buy it and to give some things for this company.
Rossignol is what, 115 years old mammoth? How do we go about craps waste reduction?
Yeah, we are working hard with all the teams in Rossignol to reduce our impact. So we try to reduce our waste by developing new technologies, by new processes, by using new materials. We are working also on how can we recycle our skis. So now we are engaged in a project where we are shredding the skis, removing the metals, and then with the mix we have, we reintroduce the particles of skis as a filler in new thermoplastic to rebuild new components for the skis.
Jean-Christophe is even more drastical. Do you ask my philosophy as a professional or as a person? This guy won a silver medal. He was a runner-up at the Tour de France. He said, well, sport is secondary. If it's about being sustainable, okay, but if otherwise we have to make a choice at some point, you obviously said, well, in sports, we're not very much sustainable. We can always do better.
Yeah, it's sure. So yeah, we travel all over the world, and just this, it's quite a lot of impact on the earth and so on. So we have to take account about all of this due to the situation and the environmental impact we have. So yeah.
New composites are going to be a bit more sustainable friendly, Thomas?
Yes.
They should be?
It should be. And they will be. We know with our different partners regarding the raw material, by example, that they are really working on these topics. It's very important for them. By example, they are studying how to use green energy to transform the raw material. And also they are thinking how to recycle their material after the life of the product. So we are going to launch several new projects, and we are going to work very closely with our partners to be focused on sustainability.
You've heard it. It's about research, it's about development, but it's about exchange communication on a constant basis. It's time to wrap it up. Is there somebody that wants to carry a message, maybe, or is there any question throughout our audience? Please, gentlemen, here, to our experts.
Thank you. Thank you very much.
We can't hear you. Beautiful.
Yes. Okay.
Thank you.
Thank you very much, everyone. I have a question about innovation, mostly in cycling. Does innovation focus on manufacturing of the composites, like the trying on modifying the layup, for example, or does it focus on the use of new kind of fibers, of carbon fibers, for instance?
It's a huge question. Of course, we are very interesting and we are following the innovation in material, in raw material. You speak about fibers, the resin is also important. And the most of time, the process is adapted to the material that we are going to use. So studying and following the innovation in material and processes are very, very important. And more largely, to have a bigger overview of the technology, the techniques, the software, are also very important to develop and follow and to be efficient in efficient.
Thank you.
Okay, you guys, I'm gonna thank this gentleman, Étienne Hubert, Xavier Roussin Bouchard, Thomas Dupont, Jean-Christophe Perrault for their expertise. Our second panel is going to be on how sports and technology are strongly linked and have a strong bond together to get more innovation. Very last question, maybe? Thank you so much, gentlemen. Thank you for this morning and those great, insightful feedback and returns on how we can better perform and try to be sustainable. Cheers. The athlete is the CEO of his company. Interesting to hear that. And even though if it's about research and development, it's all about the athletes say in the end. Team Holland for your second session and second panel. Thank you, team, to join us. You have your own mic? All right. Let me leave the stage.
Hello, everyone. We have an interesting panel coming up. It's very interesting listening to the previous conversations, because hopefully they will link together and we don't repeat too many things. We have an eminent panel. I'd like to welcome them onto the stage now so we can get underway. Jan, would you come here? First of all, Jan Anders Mansen, who is a professor in the United States. He has a long background in the composites business, probably 30 years. He's worked with the Olympics, with the IOC. He's worked in sailing with the America's Cup. He's worked with cycling as well, and particularly with swimming, although fortunately he's not wearing his swimming costume today. But so Jan is going to introduce the session. I'll just introduce the other members of the panel first, however. Next is Ophélie. Ophélie, would you like to come on? So Ophélie is a doctor, and not a medical doctor, obviously a scientific doctor, and works with DEMG, heading up their R&D, and is going to talk to us about some very interesting projects that they've developed, which in the circular economy, which we've been talking about a lot. And of course, DEMG are a French company, they're an international company, and they're doing some brilliant things, so thank you for coming. Next is Mark. So Mark Michael, how do you pronounce your surname? Melka. So Mark is from Torre. Some of you will know Torre, most of you will. They're the largest carbon fiber producing company in the world, I think. And Mark looks after their innovation team, effectively. New business, etc. And is based in New York. And he's going to be sharing some stories around what they're doing and what's currently happening in that part of the industry. And finally, would you like to take a seat? Damien Cesario, who's the founder and CEO of V-Carbon. V-Carbon, again, a different company, who are very, very focused on the circular economy, and particularly in the, if you like, second life for carbon fiber. We've heard a lot about that today. What happens when you have all this wonderful equipment? What happens to it next, and what can we do to make sure circularity is appropriate, particularly in sport. And why it's interesting in sport is these guys are not very famous for what they do. They should be, because all the stuff they do forms the basis of all the equipment that you use. And it's interesting, I was saying to Mark that Torre is a huge company in carbon fiber that no one's heard of outside of this room, probably. But actually, almost every sporting event in the world will have some of their core product within it. So how does sport help to make innovation more famous? Well, let's hear a little bit more, first of all, from Jan.
Okay, thank you very much, Tim. So I will start to put a little bit sport innovation, what is the landscape that it exists in, and what puts some of the limits, and then some more emphasis on what's going on in the composite world and innovation. So if I can have my slides on the screen here. Okay, there we go. Okay, so when we deal with sport, there is some important parts of it. It's about excitement. It's about excitement in competition. It's about excitement of our life and the fan experience we get when we deal with sport. There is another one, it's safety and health. We have to make sure what we are dealing with is safe, it's healthy, it's part of the image of sport, it should be the image of sport, and we have integrity. Integrity means it's good for our kids, it's good for us, and in here we have a lot related to our green agenda coming in. So we have to have this clear for us when we deal with sport. And in those interfaces, that sits technology. And this is kind of what we're talking about here. I'm going to give you another Venn diagram here, and that is what is the value? I always, when I deal with sport, I will say, I deal with sport, but it's beyond gold, silver, and bronze. And what is that value? Yes, there is a competition space. That's the most important. That's the one we know about. That's the one that have tradition, is the entertainment. But the fastest growing part of that is the lifestyle space. And the lifestyle space is about health, about freedom, it's about being with a comradeship. And here is a growing market. And here we have to have the green agenda really focused and where it's going to have impact. And then there is a societal space. Is it safe? Is it green? You see here it's the rush hour in Copenhagen. And we have to see how sport also have an impact on the general society. In here, it's about communication between those two. How do we communicate? How do we storytell in it? What kind of impact do we have with it? Not just talking about what is the impact, what do we do with different communities? And we create new market, new products. In here, it's a lot about technology and information management. I think this sets a little bit the landscape of sport and what we should have in our mind when we deal with it. Then we can look at what sport is extremely good at, and that is to integrate emerging technologies. We heard about, when we talked to the people before us, they said about, yes, it's about interaction with the athlete. I think today we have a tendency to innovate. We say maximum stiffness, lowest possible weight. That's why composite comes in. We see now a lot of equipment get nervous. Bicycle, tennis rackets, skis, they get nervous. They're not interacting with the human brain anymore. This is actually one of my research fields. And I think the next generation of equipment development is going to be about feel and control in relation to the athletes. We have new competencies in computer science. We don't do many prototype. We do it via simulation today. Human modeling advances tremendously. Digital manufacturing, now we can start to personalize much more. All in information and communication technology, integrated sensors, get more information from the equipment, use that in AI and machine learning to take the next step. Nanotechnology, integrated sensors in close wearables. Material science, new materials that comes up and get used very quick. And then we have sustainability. And sustainability have two sides. They have to be green, environmentally green, but we have also make it green from an economic point of view. If it's not green from both of them, it's hard to sell the concept for the large public. And that is sometimes where the struggle lays. How do we make it economically feasible for the general public? If we see all that, we can also relate to earlier morning what Marie was talking about, the Olympic agenda 2020 +5. One of the 5 points in their agenda is about sustainability development. So IOC is leading it from their point of view, and it influenced federations, and by that, the mass of people. I think it's important to see this relation of it. Now, if you take a step into composite, and if we look at the green, is we say adaptation time for new technology, and the blue is more the life expectancy of that technology. If you take aerospace, very much driven by advanced engineering, 12, 15 years to adapt a new technology for use. Then they use it maybe for 20 years. Hard to get in, but a very good customer at the end of the day. Automotive, very cost-driven. Maybe it's 6, 7 years. They use it for a platform length of 10 years, that technology. Sports, 2, 3 years. And even faster is consumer electronics. And even faster than that is fashion-related. If you see those 3 last ones, they grow together today for the general public. So we have a very high rotation of new opportunity and new technology growing there. It even eats a little bit into automotive today. When we buy an electrical car, it's about features inside the car. It used to be horsepower and things like that. Now, those 3 is driving a very fast rotation of technology and innovation. So how are they linked? We say aerospace, automotive, and composite, and sports, sorry. Yes, no doubt, aerospace, they made all the background research to say it's so reliable, so we can even fly in it. So, I mean, that was setting really the stage for it. Then they also provide a competence platform then when they start to develop light cars in composite. They were the one that provided a competence platform. And new material forms that the bike industry could use or the sport industry could use came from those materials. Now we see from the automotive back up to aerospace, it's about cost-effective, high-rate manufacturing. That's what they have developed, and now giving back to when they look at the flight mobility. And then smart field experience, really smart field experience. Bike developer, bike designers, very good on that. And there is where we say it goes back up to the knowledge of the aerospace. Between here, automotive to sport, production automation, definitely been a big part. And in the other direction, delicate, smart performance optimization. Here is kind of our knowledge or change between those three, and they gain from each other. It's a positive relation of knowledge sharing. So my final slide here is to say, I am down for swimming and also for a bike, for the World Aquatics, previous FINA, and now for the biking industry. Done the homologation of new technology, how we can allow certain technology to be certified and used in those federations. And so what is the playing field for innovation? And this is how I also worked with the International Olympic Committee. There is some borders that we have to respect, but we should maximize that green field. And that, what are those borders? Yeah, we need a level playing field. It should be fair. It should be the same for everyone when it is for competition of highest level. And that is accessibility, but also affordability. So everyone has a chance to have this technology. On the bottom side, there is a limit about safety and security, both for the athletes and spectators. On the left side here is the tradition of the sport. We can develop things that we may lose connection to the sport. Absolutely, the best way to do a bicycle is to lay down and bike. That, when aerodynamics is 70–80% of biking resistance, so if you lay down, it's much better. Who want to have your kids laying down on bicycle under their cars? You can't see them. No, it has to have a tradition of the sport that we maintain. And that also keeps the public's interest. And then on the other side, there has to be a business side. We should maximize this. So we get sponsors, we get people involved in the sport. Otherwise, we lose a lot of the financial resources for the events and for the athletes. So there is the playing field. Inside here, there is the athlete, there is the governing body, the federations, and the industries. If you look here between the athlete and the industries, their job, push all the limit you can. That's their job, and we should encourage that. Then between the federation and the athletes, keep the value of the sport. So it's a value for the athlete to stay involved in the sport. And between the federation and the industries, sport evolution. An evolution that is positive, it's progressing, but it has to be in controlled fashion so we keep the level playing field and so on. I think by that, I stop my presentation. I hope I set a little bit the scene for innovation in sport.
Thank you. Thank you. So I think that, can you hear me now? Is this on? It is on? Yes, okay, it's on. So I think that helps set the playing field, if you like. It's not easy to innovate. It's not quick. You can't come up with an idea, make it happen, and it happens in a week. There are lots of hurdles, and it's a big platform to play on. I'd like to ask Ophelia now if she would speak to us about what DEMG have been doing, which is a fantastic innovation that's now alive and well.
Thank you. Oh, no, sorry. So hello, everyone. So I'm Ophélie Westphal, the Research and Development Manager at DEMG Atlantic. DEMG Atlantic is one French plant of DEMG Group based near Nantes, in the west of France. I'm working with a team of 6 dedicated to thermoplastic composite processes. I'm here to talk about shoes, but it's composites. Not carbon epoxy, yes, but it's composite because it's made of different polymer. So who is DEMG? DEMG is an innovative plasturgy group who creates and produce and manufacturing. Oh, sorry. The problem with the, I don't know why this doesn't work. Yes. We design and manufacture high-performance plastic and composite solutions to promote decarbonization. We have 14 expertises in plasturgy, and we use it to accompany our customer from the eco-design, with eco-design advice until the end-of-life strategy of the product with recycling processes, for example. In just a few figures, in 2023, we achieved a turnover of 100 million euros with 800 employees. And we have 3 R&D centers, 5 plants in France, 2 in Romania, 1 in Germany, and 1 in the United States. So, yes. So, how did we get involved in the development of these soccer shoes and sporting goods? It's too sensitive. We made, for years, we made automotive product using short fiber polymers and injection molding process. We then began to work with continuous fiber reinforced composites for aeronautical application by integrating stamping process. And more recently, we worked with major luxury brands to develop suitcase shells in SRPP materials. SRPP is self-reinforced polypropylene materials. And at this time, we discovered that the designers are the king. So we have to develop very specific and complex process to achieve design constraints, small radii, deep shapes, and other. And after this adventure, Decathlon came to us following this luggage process to develop a new soccer shoes, very innovative soccer shoes, to challenge durability, to achieve a better durability than the classical one, and recyclability. And we use all the expertise we developed for the luggage process for Decathlon to prove it's possible to do that in France. And just in one-step process, so net shape process, we use only one step. No. Oh, sorry. Why is there? Okay. Okay, so oh no, sorry. I don't understand this. Why is? Why is it? I don't know how it works.
Do you want to go back a step?
Oh, my head. Well, okay. Maybe with your arms first. So it's not me. Okay, without
technical problem.
Without the slide, maybe. So, sorry. So I continue. The traction compressor, so it's the shoes, a big name, traction compressor, has been developed by for Decathlon. Thank you. No, for Decathlon, thanks to a real dynamic partnership between us, DEMG, the knitting partners, knitting suppliers of the preform, the raw material suppliers, and the knitting machine suppliers. We developed and researched and developed combination, a very specific combination of materials and socks architecture to meet the technical requirements of the brands, players, sensation, abrasion resistance, durability, recyclability, comfort, for the player. We then developed very specific tool and processes together with the SOX architecture and raw materials to achieve a net shape process. So just one step, we can just using one step process to make easier to produce in France. So the Traxium V1 has been tested by D2 players by the end of the development phase, and Decathlon launched commercial tests in January 2023 with 1,500 consumers. And following the feedbacks of these consumer panels, we are working on the version 2. This experience really forced DMG to streamline the process and innovate to reach a large-scale production at lower and reduced production costs. Yes, thank you. So building this initial technological success, we have been taken sustainability a step further by integrating waste materials in a new footwear project. So the Reborn project, this one. The Reborn project illustrates quite very well the 3R strategy, so the waste management strategy of DMG and Decathlon. With these sneakers, we reduce the amount of virgin material we use in the shoes. Sorry, we reuse post-industrial and post-consumer waste materials directly in the sole, and we make easier the recyclability, the recycling process at the end of life of the product. So the shoe is eco-designed to be sure that the upper and the sole can be separated at the end of life. So it's different materials, different because there are different functions for the sole, abrasion, and the upper, comfort. But we developed specific process, material combination and process to be sure, and SOX architecture, to be sure it's easy separating, the separation is easy in the end of life of the product. So DMG Atlantic is a pilot plant for this Reborn project. So we are working on the facilities and devices and instructions from the waste arrival to the end of the circle, so the end, the manufacturing of the complete shoes, sole and shoes. The sole here is made of 60% of waste materials, post-industrial and post-consumer. And we develop a specific process to keep the visual aspect of these different materials inside the sole. So the sole is illustrated very well for the consumer, this sustainability, this wish to use waste materials. So thank you very much for this, your attention, and see you if you want to have more information, you can see us at our booth.
Thank you very much for that. So, sorry about the technical issues.
It's 43 size, so if you can, I have right and left, so it's possible to do both.
There you go. Thank you very much. And again, what's interesting about that is, football's the biggest sport in the world, has the largest audiences in the world. And I think as we look at these types of innovations, to see how quickly they're adopted within the sport will help drive the marketplace and change very quickly. I suspect they'll be very popular. Mark, would you like to say a few words now about Tori?
Thank you, Tim. Thank you for having me here. I'm representing a Tori company. This works, so that's good. Certainly a large company. There's a lot of innovation happening in the sports segment. Not all of it gets very large right out of the gate. We have interesting manufacturing partnerships in this field and looking for more partners to get this to the next level. So I will look into what some of these innovative things are. As a company, we're nearing our 100th year of business. We have nearly 50,000 employees around the world, turning over close to $20 billion. And we have gotten the carbon fiber production based on pan raw material on the way in the 70s and grown our carbon fiber and composites business ever since, which is right around 10% of our total global business. Please don't look at this in detail. It only goes to show that we have a real global footprint. We have nearly right around 60,000 tons of carbon fiber production worldwide, and it's fairly evenly split between Japan, Korea, France, and the US. And based out of our headquarters in Japan, we're driving real innovation in carbon fiber. We're producing new materials that have some of the highest tensile strength you find in the industry, and then also combined at the same time with very high stiffness and modulus of the fibers. So really, really innovative. The Japanese headquarters also works on bio-based raw materials that go in production, which is also important for the future as well. If you look at our business units, you know us from primary structure of aircraft, supporting all the OEMs around the world. We also have space and satellite businesses. A recent example, the Mars rover that you have seen and are aware of. But there's also an industrial business which makes a lot of innovative activity for us. Examples are electric vehicle motors, and there's also business we have in bicycle frames, rims, and we work with Formula One intensively as well, which always looks for the next small cutting edge of some of these materials to make a difference in what they are after. When it comes to sustainability, we look for transparency for our customers over the entire life cycle of the products. I mentioned we work on bio-based. We have materials that I'll get into in the next few slides that are becoming truly recyclable. We also see that our customers are asking for recycled content, either being post-industrial or industrial, so waste from our manufacturing process that we put back into production, or recycled materials after the life of the product. Now I'm getting into some of the materials. So there is a range of products we have been working on over the last few years that are thermoplastics. They will follow the promise of much better recyclability than thermoset materials. You see on the bottom left of the slide there are hand layer processes or autoclave cure processes that you are familiar with from thermoset materials, epoxy-based materials that are slower rate. Now with thermoplastics we see automated processes that make for much better processability and affordability of our products for our customers, and that's some of the things we are showing here at JEC this year. One example how we're supporting the sporting goods industry, we're launching a new grade of polyamide material that has that affordability as well as high performance that makes it rather competitive with existing thermoset and epoxy-based materials. So I invite you to our booth to take a look at some of those things that can really make an impact on, for instance, bike frame, bike rim. So with some of these performance thermoplastic materials, we also see much more comfortable performance of the bicycle, less harsh of a ride, high toughness, high strength, and again, that affordability is there. Looking at sustainability, we find from our customers that, yeah, there is a high interest and a need for us to be bio-based as well as recyclable, but they are looking for parity of price and performance. And that makes it tough to do, and that's what we're working on, and that's where we have the innovation teams going after it to provide all this at the best performance at the end of the day, and that's all I have. Thank you.
Thank you, Mark. So that's interesting because that's from a huge industry player right at the grassroots of developing the core products. Damien Cesario is going to talk about V-Carbon, which is a much newer company, and it's doing some very interesting things around the circular economy.
Let's see if I can actually get this right. There we go, very good. V-Carbon is a technology company that was actually set up with the sole purpose of what I describe as fully industrializing carbon fiber. Carbon fiber is a fundamental part of the industrial landscape, covering all sectors. And in truth, there is no renewable, sustainable future without carbon fiber, from wind turbines to hydrogen to construction industry and mobility. And we're also of the view that there is actually no purpose or intent or justification trying to recycle carbon fiber unless it performed like carbon fiber. And the other caveat to that is there's absolutely no point recycling if you're using more energy than you actually do to recycle it. So I spent a good 3 years looking at the world, looking at all the technology that had been developed across the US, Europe, parts of Asia, and we're quite clear about what we actually wanted to achieve, what we're looking for, and we were able to bring it together. And ultimately, the market is significant. It is growing every year. We estimate at the moment there's roughly 60,000 tons of production scrap and end-of-life scrap this year that is actually not going to be effectively recycled. There's probably about 5% that will be recycled, and we describe it as downcycling. If you go into recycled carbon fiber, it needs to perform like carbon fiber, or else it's window dressing. You may as well be making park benches with carbon fiber, which is not a good use of the material, given it's actually producing or produces 30 tons of CO2 per ton of carbon fiber. So the challenge was clear, and what we're able to do was develop a fully integrated business that can actually deal with the type of scrap that comes from the aerospace industry, as an example. What I've actually put up is a good case study of what happens in the real world. Carbon fiber is used in the aviation industry because it effectively allows you to reduce 40% of your fuel consumption. It's fundamental, it's a future part of the aerospace industry, but there is a wastage problem. Wastage in aerospace is between 30 to 40% of all material used, and at the moment there is really no effective use for that. We are working with some of the OEMs, we're working with the tier ones, and the ambition for these companies is to actually put it back into their aircraft and to also basically move it into mobility. What we've effectively done is break down the challenge to what I describe as a compound level. I've actually engaged material experts over a number of years. I was able to find people that have been doing this for 20 years, making carbon fiber, working with carbon fiber. And what we've been able to do is effectively break down the material to a compound level. We are able to actually recycle the resin, we're able to recycle the fiber, and we've developed material formats that actually deliver the performance. It's many years of R&D, many years of technology, but I'm proud to say that we've actually demonstrated that in some cases our material is better than virgin carbon fiber. It's not going to replace it, but ultimately becomes complementary. The future of carbon fiber and the world we live in will be a case of recycled and virgin carbon fiber being used together and actually being used in ways where today virgin carbon fiber can't. What we have is a metal replacement material, and what we actually provide is an opportunity for there to be more carbon fiber production. As soon as you've actually got a genuine circular solution and recyclability for carbon fiber, you can justify using more of it. It's one of the issues in the world at the moment, and we're slowly starting to pull the covers off the business. We've been building for a number of years, and yeah, it's been an interesting journey, but we're at a point now where we've proven that we're as advertised on the tin, as they say, and we're starting to make a little bit of noise. What was exciting for us was we actually unveiled one of the projects that we actually had over the last few months. We've actually built a road bike from 100% recycled carbon fiber. It is 1 kilo as opposed to 750 grams, but it's actually performing the way it should. And it was the first time that was actually done. We unleashed or uncovered a program with Porsche 2 years ago. It was actually quite a complex part. We worked closely with Porsche for quite some time, and it was actually a 12-month LCA done on the material. What's really interesting and what's exciting about the solution that we've brought together is that our material is effectively 95% carbon neutral. There is a full life cycle assessment done. It's actually low temperature, low pressure. So what you've actually got on the Porsche is material that's effectively 95% carbon neutral. It's delivering the performance that it needs to for the automotive industry and is effectively allowing the automotive industry to benefit from sustainable carbon fiber. We are working with a number of the OEMs, and the general consensus is if you can't recycle carbon fiber, we can't use it in the automotive industry on scale. As soon as you can, it becomes quite interesting. Lastly, we're not a company that's lived off grants. We were asked to, or it was recommended that we apply for an EU grant, demonstrating what we said we had, and we were fortunate enough to receive the 3.5 million euro grant from the EU. We will be building a plant in Germany next year. This year we're going to be building some interim capacity. Our capacity this year will be circa 200 tonne. The plant in Germany will be 1,500 tonne.
Formula One?
I was going to.
Okay.
We put in the video. Yeah, no. I'm a car person. I was always of the view that the name should be on the side of a Formula One car. We were approached by McLaren last year. They'd heard about what we're delivering. Trials were done. And ultimately, the material performs at a level that it can be used in Formula One. There are some upsides as well. We're going to be working with the FIA over the longer term about how to actually bring the material into Formula One. But it's a complementary material, and it's an exciting time for me to see the opportunities for a high-performance sustainable carbon fiber. And one of the programs that we're actually looking at the moment is basically turning a wind turbine into a car. Wind turbines are a big problem. We've demonstrated that we can pull them apart, we can recycle the carbon fiber, we can recycle the fiberglass, and we can recycle the resin. So the next project for us will be to basically build a high-performance vehicle out of a wind turbine using the same materials.
Is there a video to show?
Yes, absolutely.
Can we run the video? Can we run the video, please? The video seems to... Oh, here we are.
Here we go.
Sustainability strategy is to innovate in circular economy. McLaren Racing has a history of pioneering in the material space, and now, in our 60th year, we are using recycled carbon fiber for the first time, which is a major breakthrough.
I was the first driver to race in a seat made out of bio-based flex fiber in 2020, and now I get to be at the forefront of innovation again by trialing recycled carbon fiber on the car in Austin.
We're working with an organization called V-Carbon on this. They are an innovative composites organization that are focused on developing new technology to make recycled carbon fiber viable. So the reason we're doing this trial and the reason we're so excited about it is because it is about showing that this is possible. Like, it is about exploring what can be done in the manufacture of a Formula One car to make it more sustainable. Everything has a carbon footprint. So when you take a raw material and manufacture it, especially something very complex like carbon fiber, which has a lot of different components, all of those raw materials have to be extracted, processed, transported. There's energy and fuel that go into all of those things. So if you look at a normal piece of carbon fiber, if you recycle that piece of carbon fiber, you are skipping a lot of those steps which require energy and fuel, and therefore the recycled carbon fiber component has a much lower carbon footprint.
Because it's recycled carbon fiber, it could be from a fighter jet, it could be from a road car, it could even be from a wind turbine.
Global demand for carbon fiber is set to double between 2020 and 2025, reaching about 262,000 tons per year. If just 1% of that carbon fiber were recycled, it would save more than a quarter of F1's 2019 carbon footprint.
Thank you, Damien. So we don't have long to go, actually, but I think what's interesting is that you have different parts of the industry here and a huge amount of expertise. And the analogy with sport is there needs to be collaboration and a sharing of skills. It's a big, big world out there, and there's lots that needs to be done. I think there's a responsibility on sport to talk about this. I mean, we're talking about it today because we're in a composites environment. I used an example earlier with some friends. It's interesting, you've probably watched the Netflix series about Formula One. Hugely popular, massive audience, has changed the sports, transformed the sport. There's not one single piece in any of those documentaries about technology and what happens, what actually goes into the cars. And there's something fundamentally challenging about that. So I think the more sport can talk about the changes we can make, the more we can do in football, the more Torrey can take on board with their size. The innovation from companies like V-Carbon will start to enable sport to perform at its highest level and be truly sustainable in the composites area. And I think that's all we've got time for, actually. So we've all done perfectly well. Is that okay? Does anyone have a question? We have got 2 minutes. No? Okay. Oh, do you have, was that a question or you just, no, you're not? Okay. All right, well, look, thank you very much for coming and listening, and we shall look forward to seeing people afterwards. Thank you.
Hello again. Hello again. Third session, one that truly touched my heart, and I'm sure it will touch yours as well. Sport for All is this third panel. I want to say it's about keeping your dream alive. You're about to witness two former para-athletes. They could work for Nike, Adidas, Puma, whoever, and be a great marketing campaign because their message is nothing is impossible. You got this. Amputated, wearing a prosthesis. It was a life changer for them, or a way to continue to stride exercising sports. Please welcome with us Heinrich Popov, who was a former Olympic champion back in 2012 in London. He's the ambassador, a round of applause, please, the ambassador of Autobach. Oriane Lopez, she's from the same generation. She did run back in 2012. She's now a doctor, physical and rehab physician at the French National Paralympic Committee and the hospital in Montpellier. And Christophe Lecomte, who flew from Reykjavik, Iceland. He works as a manufacturer, research and development as well. Hello, you guys. I'm worried about this guy because he's being very sarcastic, but he's a happy man. He's a fan of Bayer Leverkusen. This club is nicknamed Neverkusen because they never won anything, and this year they could do maybe a double or a triple. They're playing tonight in the Europa League.
Triple.
We're
not gonna go with two. We always came second, so we don't want to have the second two titles. So
Heinrich, you're a sport fanatic, a sport freak.
Yes.
Yes,
yeah.
Unfortunately.
I mean, like, sports challenged me in my life in the right direction. So sport made the person I am today, even after I faced cancer and had a disability. So what I love about sport is that sports makes no difference. So this is something like, you know, I was playing soccer in the beginning, and so I started to play soccer because no one was trying to be the goalkeeper, so that was my position. So then I'm like, listen, I can be the goalkeeper. Then I realized my competitors are afraid of my prosthetics, so my disability became an advantage, and I feel that was the turnover in my life. I'm like, So it's not everything is bad about my disability. There is also a good side. Let's try to face this good side. And then I ended up being a parasport athlete with a little bit of medals, but the medals was on side, to be honest.
We still think Manuel Neuer has a bionic arm, so maybe.
Maybe.
Who knows?
It's
Who
not
knows?
from us, but yeah.
Who knows?
Yeah.
Usually we say ladies first. I'm going to say last but not least, and keep Orion for the third intervention. This gentleman, Christophe Lecomte, is French, but he's been living in Iceland for 20-some odd years. You started with an internship, and now you've got a 17 and an 18-year-old. How did that happen?
Yeah, it happened. That's exactly. I was finishing my school and went to Iceland. I met this beautiful blonde lady in France, and then we went to internship in Iceland. And 20 years later, I'm still here. I'm still here. I'm still working for Roussin and having fun developing in Reykjavik, in Iceland. Absolutely.
Orion was running at the same in the same generation as Heinrich. When I looked at your profile, please help us out. Different categories, I guess, or classification. T42, T63. The last time I heard T something was for Arnold Schwarzenegger and Terminator. What does that mean?
Yes, we have run in 42 category, and after Rio, I think the category are different because 42 is without blade and 63 with blade, above knee amputation with blade for 63. And the other in 42 is athletes who have an impairment on knee with impact is similar or above knee amputation without blade.
Okay, and then at some point, I guess, a doctorate and high-level sport was a bit too hard for you, and you moved into becoming a doctor. Career-wise, you ended up being a doctor after your career.
Yes. I compete to 2018, and I become doctor. In 2018, I study medicine in Montpellier, and I have a double career in medical and in athlete. Yes.
Grab the mic whenever you feel, Heinrich.
I just want to add something to the classes. So you definitely have class 10 starts with visible impairment, 20 is mental, 30 is paraplegic, 40 like the short people. I don't know if it's politically correct, but 50 is wheelchair, 60 is amputation. So as less the number is, for example, 61, as less the number, as less your amputation affects you. So as 63 is above knee, so you're missing 2 joints, so ankle and knee. And when you go...
It's not a number for size of your... Okay.
No, it's just like you have the range of 10 to 20, 20 to 30, 30 to 40. And the 60 range is for amputees, arm amputees, leg amputees. And so, for example, 64, the number behind us is
below
double.
Knee.
64
is below knee, single. 63 above knee, single. 62 below knee, double. And 61 is double above knee amputation.
Complicated. It's like boxing.
You're right, 17 categories in boxing, I can tell. I'll ask you later, are there not too many categories? Because I feel like at some point you're going to have only 3-4 athletes, and maybe the more, the merrier. The first flex foots with an American called Von Phillips back in 1976. Ozur bought out his
exactly. So
device 20-some years ago.
So Von Phillips was an amputee, and then he started to use actually carbon fiber and composite. He had some friends working in the aerospace industry, and basically cut a piece of an airplane and put it and tried it out and figured out that it worked. So in the 80s, there was a development as an active amputee. He wanted to run, wanted to do sports, living in outdoors life. So he started this company FlexFoot that was acquired by Roussin around 2000. And then there comes the development and actually the manufacturing to Iceland in Reykjavik, where since then, I mean, that's for me when I started, and we are basically continuing this journey of using composite, and engineering just but to develop prostheses.
You'll see. Obviously, all the human values are at the core of all of these people are doing. You told me when we rehearsed, Christophe. Yes, I'm working in an industry, and we have to sell fast. But I also wanted to work in academy, which is a slower pace, and understand and feel like I have an impact on what I'm doing.
Yeah, exactly. I think we are. I'm passionate about this job, and working with actually people and trying to help people and amputees in that case is a big part of. It's a huge motivation. The impact that we can get on. At the end, it's basically black feet. I call them black feet. They're carbon fiber feet. They're nice. It's a cool piece of engineering, but actually. What I get from the job is, of course, using nice materials, titanium, carbon fiber, glass fiber, aerospace grade aluminum. But what's most important is putting the equipment or the device on people and trying to see what it comes out of it. So I was telling you, sometimes it's great and there are guys that get medals. And sometimes it's not that great because actually we didn't do our job really good. So there's lots of humility that comes as a designer and engineer. So I might go through that a bit later, but engineers are very unsure about what I'm doing. But actually what I learned is not to be sure of anything. And that's my
I love that.
Inspirational here. Listen to this one, inspirational there. We're very lucky to have Heinrich was a public speaker throughout Europe and the world. You still, every week, go to hospital with people that are about to get amputated. What do you tell them?
Nothing. I'm just there as a picture, as a real picture, to ask what will happen with me the next days. So for me, the connection, and this is something I really love what you said, it's the fight I have as being an amputee with the engineers. I'm like, listen, it's nice to know everything about technology and biomechanics, but if it feels not good, leave it. Let's try different. And this is something I do in the hospital. They have doctors, they have psychological treatments, but if you get someone to talk to who has the same problem or who overcome already the same problem, the motivation is way bigger. And also my connection to the amputees who really don't know what will happen in the future with them, even how can I go from the bed to the toilet, and I'm coming in smiling and they don't even realize I have an amputation. It gives you a different motivation, and this is something what also makes me happy, because the purpose of the whole technology, it's nice, everything is good, but what you said, it's the human purpose, and I really like the technology perspective on that. But you see, my leg is on the table, but it's not running, so I have to run it. So this is something it's not.
I know you're eager to put it on, and you may want to run at some point.
Yeah. But what I would like to say is it's not the technology that drives the human; it's the human who drives the technology. And that's when I see these people, and they know everything. So when I come in, so they have time. And Google is not nice at that. If you have time in the hospital, Google is really bad for you. They Google everything and they explain me, listen, this is a microprocessor control need. There is a carbon fiber feet on market. Everything. They know everything better than I know.
You tell them to
throw
it away.
I tell them, listen, you have to walk it. You have to try it. And if you go through marketing and the companies in our industry, everything looks nice. And there is no time to explain the work behind it. And if you realize, you put on the technology and then you realize the work is so demotivating, and this is what I do the opposite. I come in and tell them, listen.
Thanks to Lucien Boyer, Marie Jaillant, Global Sports Week, we've picked up people that have human values. Storytelling and emotion is what drive you to actions. I feel like I thought I was energetic. You two guys, I mean, it's like you have an X factor. I mean, the prosthesis, the amputation gave you that? Why do you carry so much energy? Where do you get that from? Oriane.
Just we like life, and we have to live the better life we can. And when I practice with child, every week, every day, I speak parasport with my children, with the children I take care, and I want they know they can, and we are here to montrer, to prove they can, and to explain all the parasports exist. And one parasport is good for him, for her, and we have to speak parasports with all people with disability to make me happy, to make me in capacity to perform.
It's
and
a
to
sports
have
summit.
Sport activities.
It's a sports summit. It's about sports. Marie-Amélie Le Fur last year said, I want to stay in the game because mentally, psychologically, it's the best treatment. Heinrich will come through. They'll go through the operation. Oriane will go into hospitals and she'll do what we call a program called La Relève, looking for the next game, because some of those youngsters, athletes, could be the next Paralympics in 2028. You do some kind of recruitment. Tell us about that.
Yes, the job is to invite people with physical disability or visual disability, and to prove they can practice. And if he want to practice, they want practice in competition, the high level, to choose the parasport is better for him, for her, and to choose with classification, with level, with morphology, with technical ability, to choose the parasport and to help to perform in this parasport.
You told me yesterday a young gentleman was distraught, thinking he couldn't do anything,
Yes.
and you're like, looking at your body frame, looking how you react.
Yeah.
I see you could become a rugby player on a
Yes.
wheelchair. And he said, "What? I can't grasp anything," and you've got answers for it.
A young man who practiced table tennis in Hubble life, and with a neuropathy, peripheral neuropathy, is lose the function to work, and he don't know what he can practice. And I tell him, I think you can practice wheelchair rugby, and tell me, Oriane, I don't have any fingers, functional fingers. Take a ball. Why? What? And I tell him, you can with gloves, you can take a ball, you can play wheelchair rugby. And after the afternoon, after play rugby and try rugby, his mother and him crying because tell me during 15 years come to hospital and measure only what I lose, and now you put on my face what I can do, and it's fabulous.
And
And
the solution comes with the technologies. Oriane said already, you can use a glove, then you will somehow overcome your disability, having no fingers and trying to push the wheelchair. And in terms of the energy, I would like to add something. You know, we as human beings, when we have 2 legs and 2 arms, we're not thinking about the possibilities we have. For example, I said already when we were talking in the back, I said, like, we have sports shoes. Every one of us has sports shoes in their house, and we look at them and we're like, tomorrow we go for a run, tomorrow we go for a run, and tomorrow we go for a run. As soon as you lose a leg, you look at the shoes and like, now I would like to go and I'm not able to go. So, and this is something that gives the people with disability this drive, you know, this extra energy and special push. So always trying to overcome and always try to prove the society that disability, Like with the day of your disability, your life is not stopping. So, and in terms of sports, and also like we're talking about performance. But to be honest, walking on a prosthetic through daily life is an own sports event. So it's proven by medical studies that as an above knee, it can happen that you have an energy need of 7 times more compared to a non-disabled. So for example, if I would be a heart-affected above knee amputee, and you would be my friend, you come to the hospital and you tell me, let's go for a walk for 1 hour. For you is 1 hour. For me is 7 hours. So of energy.
And the imbalance it can create in your back and all
everything.
But that's why you're stiff up there.
I'm trying, so I'm already old. But what I would like to say with this is like, person with a disability, when you have no disability, you can make a choice. You live an active life with sports or not. It has an effect of your quality. But if with the disability, you don't have the choice anymore. You have to do sport. It's the best medicine you can have. And through technology, this is what Oriane said, like, yes, you can do it. It's only possible through technology, but 50-50 eye-to-eye level.
You do have different pair of sneakers. We have this picture in front of us where we actually switch from running shoes to the blade. This is the running shoes from Heinrich. Oh, maybe he's gonna, yeah, we can bring a close-up and see the difference between, yeah, please do, 2012, wow, lucky us. Look, he's gonna switch shoes. Maybe if you wanna do a close-up on that, that's quite interesting. Which brings me a question, Christophe, because we're gonna get into the, I guess, ethics. Marcus Rhyme, Oscar Pistorius, as relevant and known examples. We started to talk about, well, it's too much compensation. Your answer is, bear in mind those people are lacking something from the get-go and we're not adding something.
Yeah, exactly. It's and for all the audience and the guys watching us, I mean, it sounds like easy when we look at it on TV. The guys are running so fast on the blades, but like Henry said, it takes lots of energy. And like guys that are missing a leg, it takes so much energy and motivation, and jumping out of the blade can be also very dangerous. And
Heinrich, the ratio that you gave us 1 to 7 in terms of energy, with this, it's still the same, or you're actually spending a little bit less energy?
I mean, it can force me to get to spend more energy, but the secret behind it is having less energy with more outcome. But you have to make your body physically ready for this, and this is something I can show if you want.
Oh, please do. This is improvised, but it's beautiful. Wow.
This is the possibility, but still, my back and my core have to be ready to do this.
So that's why I think it's performance enhanced, because I can't jump that high. Wow, it's incredible.
If I do this, I can only rely on my blade.
Wow. Is that why? Because Marcus Rhyme, long jump record holder, and I believe that actually jumps further than Valitz. Is that why you have a little less empathy than he does? You think this is too enhanced? I'm not saying, but where's the ethic? Where's the threshold? Where do we stop? Or sky's the limit? What is your take? Tough one.
Sky is always the limit.
Okay, I
Let's
should have mentioned Marcus, but
no, I mean, no. In terms of Marcus, and we are close friends because like I was the one who took him from the trampoline to the blade. He started with the old blade of mine, and we were in the same team and same club. So, in terms of Marcus, the long jumper, and this is something like what I really don't like what the media did out of it. So they only pushed him on the side of advantage and disadvantage. That's bullshit. He has no advantage and he has no disadvantages. So he has less disadvantages than maybe someone else who has 2 legs, but in terms of muscle pain and everything, but his amputation level, his scars and everything. So then you can see he has more advantages. The only thing I say is like, there is a barrier of how can you compare people to each other. So there is a reason why women not competing to the men. And this has nothing to do, Marcus is, in terms of an athlete, you have to look for an athlete in the world that has his abilities, his mindset. It's like Usain Bolt and Marcus, eye level. Even Marcus is higher than him in terms of professionality. But it's hard when you mix everything together that's maybe not comparable to each other. And you know what I'm afraid of as an athlete, and I know lots of the athletes in parasports are afraid of this. In terms of all this political discussion, inclusion, it's not only one-way direction. If you go to the Olympics can go to the Paralympics. Then it will become an elite class sports. And if you're not able to compare each other, you have to explain sports to the spectators. And as soon as you have to explain sports, you will lose the people.
Wow, okay, that's that. Paralympics, not because it doesn't mean disabled, huh? Because it was in parallel to. It's a good thing that there's a different exposure. You take it's a good thing that it's in September and not at the same time.
It's two big events, two
different
big
events.
And we have to explain why there are two events, but it's necessary there are two events.
Sorry, I did cut you off.
That's fine. And just like so, I have a bit different opinion about all that because there's elite sports and there's the job that we're doing as engineers to actually let people do actually what they want to do. And some people want to compete with each other, but the beauty with sport and for people that do team sport is to play all together. And of course, the blades like Heinrich or Marcus, and it's a bit sad to say names like that, but anyone can buy those blades because they're just standard. They're standard shoes, they're standard blades. But every once in a while, it seems every 10 years, there's one guy that is a bit different. And all the attention goes to that person. Actually, those blades are, okay, I'm very proud of our technology, but there's nothing much newer. There's just every time, there's a Usain Bolt, there's a Heinrich, there's a Marcus. And if those guys that are training and competing, if those individuals want to compete with their peers, I think, I'm not saying they should take their medals, or they could, but just being at the same event, at the same level, that's what sport is about, that we all play together, that we play France, Germany in football. I think that's a critical thing for inclusion, which is sport should be all about.
But inclusion on elite level, there's no inclusion anymore. It's exclusive because you have standards. You can't say like, let me run against Usain Bolt. It's not fair. Give him a backpack with 40 kilograms on his back because it's... So inclusion happens on the grassroots. Para sports and elite Olympic sports it's exclusive. It's not inclusion, it's exclusive. And based on this, like, yes, blades are available for everyone, but not for those who have two legs. You know, I was shocked because one of my best friends is one of the best German long jumpers. And he said, listen, my legs are equal from the length. His legs is longer than mine, one side and the other side. So it's not comparable. Has nothing to do with advantage. He's a better athlete. And even Oscar Pistorius, the way he ran, you know, first curve, he couldn't accelerate. First length, he was accelerating, then he had to stop because when he was going with the full speed in the second curve, he would end up...
Yeah, because of the centrifuge.
So, and this is something
energy.
Like, it's different, it's not less, it's different. And that's the reason why you have to separate it. It's not less.
This gentleman wants to be extremely inclusive because I want you to talk about your personal stories with Arnaud Fourier, for example. The link, the bond, the tie that you have with these athletes are extremely strong. At some point, you're a shrink, you're trying to be an innovator. You have to be a great listener.
Yeah, and I think also it's important to say that there's the athlete, there's the equipment provider, and there's the whole team behind the guys, which, you know, there's a prosthetist, there's a trainer, and when we work on blades or composite, just what I learned also, we often look at the bottom part. The prosthetist will look at the socket a bit higher, the trainer will look at the hip, the head, and the athlete will look at, obviously, at his performance. And it's lots of things that we need to put in context, actually, to get a good perception and a good, what I think is performance might not be performance for the prosthetist because of pain on the athlete. So it's, it sounds simple, but performance and competition. And then you need to build relationships. You need to understand also what's the event. So there's actually few things to go through.
We talked about philosophy, performance, different categories, faith, because I've heard this gentleman does never say kein Problem. There's no problem, there's only solutions. Kein Problem. Cost is a problem. It's still not very, I mean, how can we reduce the cost? Flex foot, you told me it starts with 3,000 euros, but up for a wheelchair, we go up to 40,000 euros. It's too pricey. What can we do about it?
It's very important we work together to accessibility for whole passport, for people with physical disability when they need orthosis or prosthesis or wheelchair. We have to work together with individual provider, with athlete, with engineer to improve the capacity to be the parasport more accessible. Yes.
Only Lucien Boyer buys a brand new car today. We all loan our cars for 2 or 3 days or go through rentals. Unfortunately, there's no second hand in prosthesis.
It's not allowed because it's a medical device and a reuse is not allowed. So, and I think this is another problem. And I was listening very interested in terms of recycled materials, reuse. Maybe this will will have a big benefit on our industry. I know that some of the competitors in the industry already thinking about that. But to be honest, is like, how much does quality of life cost? You know, we're talking about 3,000, 4,000. I'll give you an example. In Germany, insurance company, the money they use for medical devices like prosthetic wheelchairs and orthotics is the money they use on a half of the day for pharmaceutical stuff. So, and this is some different perspective, different thinking. I think physical education and in sports in general, making people aware of what's possible, motivate people, giving them the chance to use the products that are available in industry. I hope there is no one from the pharmaceutical industry here, but give us a little piece of the cake. I know you will sell less painkillers when the people start to get more fit. So, and this is something like working together, educate each other, and yeah, this whole rules, regulation processes, I think you're aware of. I think 80% of your work has to do with papers and not.
So it's recorded. I'm not going to say it.
So that's the cost. Huh? That's the timing. That's the paperwork that makes it expensive.
So medical device, and there are rules for good reasons, but medical devices are well regulated in US and obviously in Europe, because every once in a while somebody makes a big mistake and there's a medical problem. So we follow those rules for prosthesis. And that's part of it. And that's been changing a lot for the last 15 years. Especially because of this French guy that put very bad silicone in the breast implants. So if I see this one, but we are following those rules, and it's taking a lot of time, and there are lots of documentation and testing to do. But we're all, I think, the sustainability, end of life use, possibly getting the prosthesis to be used longer. We're all there. It's all getting there because it's obvious that
multi-use, multitask. You do have an announcement to make for us.
Yeah, well, we're also working to have one devices that could do more things, that you're obviously going jogging, going running, so you don't need the need of two prostheses.
So the switch that took Heinrich about a couple minutes, you wouldn't have to do it?
So you would actually maybe not go run or jump like Heinrich, but you could go and play basketball on the same foot, on the same device. You could go in the water. You could.
Hey, white men can't jump. I can tell otherwise now.
Exactly. So that's the idea, to do more with one leg or one foot. Yeah.
Wow.
And this is like the following the rules. It's nice, and this is a very nice political answer. I know I'm talking as a user, you know, like not someone coming from the industry. I'm coming from the industry, but this is like I have one colleague here. That's the reason why I'm the nightmare for our engineers. So there is a certain time where I say, like, I'm not interested in rules and regulation and engineering, whatever you do. Make my life easier. So, and if we get this perspective and this regulation, it's nice to have a regulation. It's also good to have a regulation, but sometimes think about solutions before you think about documentations.
You kind of answered that. It takes a while. It's a lot of timing. And we're not allowed to make it profitable for another children. So sustainability-wise, we got progress to make as well. Yeah.
We have to make me good life, great life, improve the quality of life for all with accessibility, with the cost of technology, to improve the life.
Maybe you ask Oriane, or I can also answer this, but ask her how many children.
Ask her.
How many children are running on your old prosthesis? Are you giving it to other ones? As soon as you finish, did you give it to other ones? See, I do the same. So this is normally illegal what we're doing, yes. But somehow.
I want all the
yes, so we have it in like. It's we can't use it because, like, maybe, so for example, myself,
common sense.
I got too fat, so I can't use it anymore. So I put on weight, so I can't use it anymore. But there is someone who can use it. The industry is not allowed to do it.
You gave me a very structural example a couple days ago. You said, let's say a carbon fiber prosthesis has a 10-year life expectancy. The person dies after 5 or 6 years of diabetes. That prosthesis is good for another 5 years, but it's gone. It's to the trash.
And just to point out also, there's plenty of good associations out there doing running clinics, and that's something that actually we participate. Some of the carbon fibers that we do, they have little defects, visual defects, and they are sent to, as a company. That's so we can't really put it out, but there's lots of people out there outside of companies that are actually collecting those devices and doing running clinics, letting kids to try. So maybe we need more of that also. That's a good support for the community.
There was a guy, V-Carbon or something like this. He's recycling carbon fiber. Maybe we can send it to him, and he will send us some new material to do new prosthetics. So. And this is something like the solution for the future comes with an ecosystem. We need to learn from each other, educate each other, use our industry. It's not good to keep the industry closed, so we need to open up. And so my father always told me when I was growing up, if you steal with your hands, you will get a problem with me. But if you're not stealing with your eyes, you will get a problem as well with me.
Wow.
So, and this
Think outside the box. Like I said earlier, it's got to be a fluid conversation. If you want to raise your hand, if you have a couple questions, we're about to wrap it up. But you can tell, shake, shape, and share. Those are the movers and shakers. Action comes with emotion, those storytellings, and that's what they try to do. They've lived sports to the highest level. And they try to find, it is heavy indeed. The one from 2024, I got to be proud of. For Paris 2024, it looks like a sun. It's kind of bright. This is heck heavy. This is almost a kilogram. I don't know. Huh. You broke my neck. Anybody has a question? No? So you understand that's what they do. Go into hospital, helping those youngsters out. We did cut Oriane off, but there's this family that's eager to have the next wheelchair, and you told them, stand by for another 60 days. I have a second hand, please. But I guess when your child is disabled, impaired, you have a tunnel vision. So you tell them to récemment, tu as dit à quelqu'un, attendez, j'ai une chaise qui est parfaite pour vous, tailor-made, almost tailor-made. They want to spend another 40K on something else. You tell them, give it 45 days, and I'm going to make the future bright.
Two little girl with a spinal amyotrophy, 1 2 years old, and the other 4 years old, and she meets together all the Wednesday with me in hospital, and the big 4 years need to change wheelchair. And the other girl, 2 years and a half, needs this first wheelchair. And say, wait, the other girl have the new wheelchair, and you take this wheelchair. And it's okay, it's your head, it's for you, your morphology is your wheelchair. Wait, and it's not necessary to buy another wheelchair for you. Not buy a new wheelchair, because you have the wheelchair for 1 year or 2 years, and after, yes.
Common sense. There's 2 ways to know if an audience been captivated. They're either cheering and rally, or they are very quiet and silent because you guys caught their breath. I've had a blast preparing this with you guys. We'll say go die Werkself for Leverkusen. And please keep exchanging and spreading the word out. That's our will help out being very proactive on the research, on the development, and on you guys' feedback. Thank you so much. Heinrich, Oriane, and Christophe Lecomte for this third session.
Thank you. Thank you.
You just caught me with that jump. That's an enhanced device.
From my girls,
Huh.
the little ones. Every morning when I'm ready, when I go to the bathroom, I have different stickers on. So, and this is also like what is maybe important, like make this components or this medical devices more touchable. So my kids growing up with this by putting stickers on it. I'm the coolest dad on earth. So no other kids, they go to the kindergarten, they're like, we put new stickers on my daddy's leg. So the other girls or the other kids in the kindergarten, they can't do this. And this is something like, give a different perspective on a negative, maybe this in the beginning is negative, the disability, but it can turn positive. And if you give this positive view on that, it's easy to overcome.
Great dad and a great friend, I'm sure. A bionic man, that's what he tells us. Okay, these were our ex-men and women. Thank you so much. Fourth and final different panel. Yeah, don't keep your leg. I'm gonna grab my phone though. But I'm not gonna Google anything. I'm gonna trust you guys. Surfing, gliding, it's all about water sports and what the utilization of foil is doing for the future. Luca is going to be your moderator. Enjoy that.
Okay, so welcome everyone. My name is Luca Rizzotti. I'm the moderator of this talk, and I'm here with, I'm going by order there, with Fabio Bressan from Persico Marine, Tom Laperche from SVR Lasertig, with Romain Caquia from CDK, and David Depremorel from Finoconc. We are talking about foils and composites. My name is Luca Rizzotti, as I mentioned. Forgive me, I will be using the phone simply to look at the questions. I'm not going to chat, but you will see me looking at the phone from time to time. I'm from the foiling organization. The foiling organization is, let's say, the industry body of foiling. Among members, we have everyone that is involved in a professional way in the foiling world, which includes the boatyards, the designers, the professional teams, universities, research centers. It's a new entity that we formed just over a year ago. But just to give an idea of the industry size, the overall nautical industry in the world is at the moment worth 60 billion euro. Foiling alone is 1 billion, so 1/60 of the total. But the reality is we are growing at normally at 20-25% per year. So I think we're going to reach 2 million, pretty sure. And we keep growing very fast. And the companies that are at the moment involved in foiling worldwide in a way or the other, whether they do foiling only or partially, are, from our calculation, around 1,750. So not a small number. And here with us, we have some of the most representative people in there. In the next slide, just very quickly, because we are talking about foils, I wanted to give you an idea of where this comes from. Giving you first, when foiling was discovered in 1861, basically was an English engineer, which was an aviation pioneer, even before the Wright brothers. And he was trying to find a way to see the turbulence that in the air is quite difficult to see in any kind of wing. So he put wings under a boat that was towed by horses on a canal, which is called the Surrey Canal, which is near London. And to his surprise, the boat lifted. And that was the discovery of the effect of foiling. Then, not many years later, the Wright brothers came with the very first airplane in 1903. And then a couple of years later, an Italian, Enrico Forlanini, was the very first to have a self-propelled boat on Lake Maggiore. I think it was 1906 or 1907. And the interesting thing is that with an engine of approximately 100 horsepower, he was already doing 20, 30 knots back then. But of course, how did we progress from there? Because foiling stayed on the fringe for a long time because of the difficulty in, on one side, the design, on the other, the availability of materials. Still, composites started playing a role. And on the other side, I think another important role was by the computing capacity. At some point, together with the age of composite, we had the age of computers and CFD, which is computational fluid dynamics, and everything that is computation started giving us answers faster than we could before. So at some point, composite started playing a role in boats. David, you are from Finoconc, which is a design firm that has been involved for a long time in racing yachts. So tell us a little bit on when did we see composites on boats for the first time?
Well, to make a very short answer, it's in the 60s. Back then, sailing wasn't really a sport. It was called yachting, and it was an activity for rich people who were able to build large boats. They were mostly done in wood or in metal, aluminum, steel, and then aluminum. And around the 60s, with the advent of mass tourism, and the first mass-produced boats were, they're not on the screen, were those small, I see them, yeah, those ones here. This is the first series production from Beneteau. So they were actually fishing, well, for your weekend fishing. And so it was not really sailing. They had sails in the mast, but you couldn't call that sailing. So that was the 60s. And at the end of the 60s, beginning of the 70s, this is the first boat that was actually produced, a real sailing boat that was produced in more than 1,000 units. And then at the end of the 70s, beginning of the 80s, Beneteau had become a large sailing boat company, and that's when sailing became really a somewhat popular sport.
Especially in France, where I think you did a good job by avoiding what we did in Italy, which was making yachting an exclusive thing, luxury thing. All the advertising and publicity is always about luxury. Huh? While in France, it's always been, it's a sport. It's a family thing. Just get out there. And that's one of the reasons of the success you have also in racing in your country, right? So, but then composite started in the boat. I guess fiberglass and this kind of use were the very first in the hulls. But composites now are used in lots of the parts of the boats. Tell us a little bit of where these parts are now.
Well, in the introduction of more composite, especially high-tech composite, came from the racing part of sailing. The first, the hulls were composite quite early, as we saw, but then the next item was masts, carbon fiber masts. And then the carbon fiber that was in the mast came into the hull as well, and in the keel, because since we want the keel to be low, we have a light part at the top and a very heavy part at the bottom. And so this is, mast, hull, and keel fin. And then on modern boats, a few years after that, I think I have one more picture, probably. No. Okay, so no worries. The rest, there are composites in a lot of parts that no one suspects. There are composites in the sails. There are, this one. There are composites in the foils that carry the boat above the water. So those, the modern racing boats are, as we say, they are carbon fiber from head to toe, basically. It's everywhere, in the deck gear, in the sails, in the hull. Well, you find it in places you wouldn't even suspect. In large cruising yachts, you can't even find them in the toilets.
That's very true. Romain, you are from CDK, which is one of the most known, let's say, boat yards that is involved in the racing scene, the ocean-going racing scene especially. The boat that we have just seen, I think, the IMOCA.
Yes, we have seen some IMOCA from CDK. Not this one, but the previous one.
It's the flying one.
And the flying one, too.
Anyway, your company is involved a lot into foiling boats now. But that wasn't, at the beginning of CDK, that wasn't the case. How was the transition for a company like CDK for serving a community of sailors that suddenly moves from displacement or planing into hydrofoils? You need new technologies, you need new production capacity. What was it for you?
For CDK, we are building the fastest offshore boat from 40 years. And with the introduction of hydrofoil, so we can see the boat of Tom here. With the introduction of hydrofoil, the boats are very faster, and because at the beginning with the first composite boat, a lighter boat was fast, but with the introduction of foil, there is more impact, and they need more structure, so the boats need to be heavier and stiffer. So now we are building a heavier boat, even if they are going faster. And from 10 years now, we only build a foiling boat. So the last non-foiling boat we built was IMOCA 60 Massif for François Gabard, he won the Vendée Globe with in 2012. But it was the last non-foiling boat we built.
Yeah. So that's quite a change,
Yes,
I would
it's
say,
a big
to go
change.
from making some foiling boats to only foiling boats and nothing displacement. So if somebody now walks into your yard and say, I want to build a displacement, what are you just gonna, we only do foiling. Okay, that's a good one. So how did you adapt to this new demand? What is the technical requirement? What is the challenge for the company? What do you need to have to follow this?
To build all these new boats and new and foils, we well known we were producing carbon mast, so we well known the process of the technology to prepare carbon and epoxy built in autoclave. You can see the autoclave, and but for the hydrofoil we adapt this process. It's generally more than 100 millimeters of thick solid carbon, and laminate on the mold and cure in autoclave. So we quickly acquire a new autoclave, very large one, 4 meter diameters, to build this kind of new shape, a new shape of foil.
Yeah. So what is the largest foil you've built so far?
I think this is the new foil for Tom.
You are demanding, Tom.
Nearly.
How big is it? Just to give us an idea. How big is this foil? In length, more or less.
I think it's 8 meters of the leading edge is 8 meter long.
Yeah.
8 meter long. So with all the different curves.
So quite big, Tom?
Yes, quite big, and it's almost 500 kilos.
So tell us, Tom, tell us a little bit about you. You are a sailor. You are from SVR, a team that has an Ultime, which is one of these gigantic trimaran. We will see the pictures soon, I hope. This one?
Yes, my multi-hull today is this wonderful one, SVR Lazartigue. I was involved in a big race, for sure the biggest challenge of my life at the beginning of last January. We started from Brest to turn around the world, solo-handed on this kind of engine. This is very fast, and
how fast does it go?
How fast? It's the maximum speed is more than 50 knots, so quite really almost 100 kilometers.
Yeah, near cavitation speed.
Yeah. And so I grew up in Brittany, and I have always dreamed about sailing on boat like this, on multi-hulls. And so it's like a dream today, and I've sailed on many boats. I made an engineering school after my at 18th, and at the end I start for 4 years on the Figaro class, so to improve my solo-handed skills and mental skills. So it's very difficult to win and to have. And for 3 years I'm with François Gabard on this SVR Lazartigue. So it's beautiful and very interesting to develop, to share with a big team, a wonderful team.
Yeah. And you just participated in the Arkea Brest Challenge. Is the right name of the?
Yeah, Arkea Ultimate Challenge was the course we were supposed to turn around the world, and I crashed the boat near the South Africa. So after going south, middle of South Atlantic, I heard something in the water.
Yeah.
I can't know exactly what it is. And now the boat is on a ship coming back to Brittany. It will be in 15 days in our company to take care of it and to rebuild it.
Okay. And I know that you are an engineer as well, right, Tom? And you started working in Merconcept, making some of the parts that ended up in the boats that you ended up sailing later on. So composite have certainly played a big role in your personal experience and also in the boats that you sail. Tell us, what do you think this composite pathway is going into these kind of boats? What will we see next in terms of use of composites and performances? What's happening, for example, is also in Merconcept.
Yes, I did my internship in Merconcept and in the design team of this boat. So I'm proud I worked on some mechanical systems which are on the boat now. Yeah. I think talking about foiling boat and this kind of multi-hull, the key to fly today is the weight of a boat, but also the stiffness of the boat, and the composite materials enable the boat to fly the last 10 years. And like you said at the beginning, foils exist since and the idea of foiling and created a lift with water. Yeah. It's more than 100 years ago, but really the fiber carbon enables now to have a big boat really stiff and permits to fly.
How long does it take to go around the world for a new team? What is the record at the moment?
Right now, the record is 40 days around the world in crew team.
Yeah.
Solondid is 42 days, so it's almost 30 knots average around the world. So it's really fast, really demanding.
I remember, maybe I'm too old, but I remember in 2000 when they did the race with these gigantic boats. There was Philips and Enza and all these boats. The record was 65, something like that back then. And
yeah, it was around 60, 70 days.
And we cut 50% in
the
20 years. That's amazing.
The 80 days record were broken sometime in the 90s.
Yeah, in the 90s.
In the
so
late 90s.
We're cutting half, which is amazing. And that's, of course, because of foiling and carbon fibers, right? That's the reason. Fabio, you are from a company that works from Persico, which is a manufacturer, of course, of boats and foils and carbon fiber. We are talking here about big racing yachts and so on, but foiling, of course, is showing. What I think is interesting is that once upon a time, let's say, the sailing technology that was coming from the Cap or racing was flowing mainly back into sailing. But what we see now is the difference is that foiling is making an impact in everything that is not just sailing, but in the nautical industry as a whole. But that means that if we want to go numbers, we need to have some form of mass production and standardization. How do we make this step? What do we need to do to achieve that? Because, of course, we need to improve quantity capacity. So we need to be able to produce fast, and we need to also lower costs if we want to make it affordable, let's say, for the masses. Of course, it's not the right term, but you know what I'm aiming at. Tell us a little bit about the job that Persico is doing in this direction.
Thank you. First of all, thank you so much to invite me, and thank you, the JEC organization. It's an amazing event here. It's very interesting. And all of this conversation, moving from the beginning of my career where the foiling was not hydrofoil. We discussed this morning about the fact that the hydrofoil changed the transportation concept, because from the basics, we understood that you can save 80% of the energy to move, and transport something with the hydrofoil concept. Having said that, it's related to the speed and the forces involved. You move from one order of magnitude, and that the foil become one of the priority elements of the idea of transporting something on the ocean, right? Here the point is the cost of the material it's very expensive. We know we have to use material that allows certain performance in strength and stiffness. And you want to design a foil very thin because that is a real advantage. Having said that, it's very complicated today make any standard because every single boat or every single can be a motorboat versus a sailing boat is requires some different boundary conditions. So one of the first challenge on standardization is identifying something that is similar one to another. We noticed during the America's Cup, probably most of the people already know, but we provide the foils, the hydrofoil for the entire cup for all the teams. And the first generation of design was very different. So we moved from one technology to another, and still the current technology, it's not suitable for an automation or eventually a mass production. So there are limits on that. So one of the points, and we had that conversation, Luca, a few days ago by phone, is certification programs that can probably allow and help to make some boundaries. So if we intend transplantation on a concept like a motorboat, standardization and certification will be the first stage to allow the design to be similar. And with a similar design, you can probably identify a process that can be more standardized inside in our manufacturing facilities. If we want to make an analogy, and then that nice the fact that the sponsor of our foil outside is Pirelli. So a foil or hydrofoil today is the equivalent of tires, and Pirelli is, right? So tires is a specific element of car transportation, and hydrofoil will be the same one on boats and the ocean transportation. So requires some standard. Tires, they are very well defined for standards. Even if you have a pickup or a small car, still in a standard. So first process is certification, understanding which kind of standard that they can define the structures. And then after that, looking for the process, we have a picture now of a robot that is demonstration of where we are going today and intending the automation, one of the first critical steps in our roadmap, technology roadmap. But we intend to help certification, and we intend to help or introducing some of the technology that Persico knows about the automation. So that's the first key for allowing.
And then to bring to the next level, what do you think are what needs to be overcome to make it mass production and lower the cost? Is that labor cost? Will we have robots working 24 hours or reusable molds? Or what are the strategies that, let's say, in general, perhaps Persico is putting in place?
So definitely the automation is the most important direction to go. There are no doubts about that, and I'm sure this is not the only conversation today. On the last few days, we saw on this conference multiple automated systems. So the robot is an example. There are limits on the thermoset material, unfortunately. So thermoset material requires some curing process. Avoid the autoclave is the first important step. And consolidation of material in thicker parts is a challenge today. What we notice are, because the hydrofoil is under extremely dynamic conditions, now we discovered, and that part of my personal experience on the America's Cup, and the first one was the hydrofoil was in San Francisco, the delamination and the propagation of failure inside in the foil could happen, unfortunately. So for race condition is pretty good, but if we are thinking about the standard and we believe that new transportation, they can take hours, that delamination, that's not acceptable, right? So materials and new systems, it's necessary. So that's the key. So the automation today, it's not reached that level, in our opinion, but that's the only way to go.
Thank you, Fabio. David, back to you. What are the projects or exciting things that are coming that we will see soon on our seas and lakes?
Well, first of all, we're putting the finishing touches on the boats that we designed recently that will sail in the next Vendée Globe, the single-handed round-the-world race, starting in November this year. And at the same time, we are starting working on the next generation for the Vendée Globe 2028. So that's one thing. And we're also working on a very large cruising catamaran that will be built in carbon.
Define very large.
Very large,
everything
38 meters. 38 meters.
Okay.
That will be built in carbon fiber. And we are trying to minimize the impact of such a big build. So we're working very hard on reducing molds, which are very large part of the environmental impact of composite, one of composite parts. And we also work on using decommissioned aerospace carbon fiber so that we do not have to produce all the carbon fiber that we will use. So that's something we are really trying to...
When you say decommissioned, is past the use date for
example,
aerospace?
Or end of rolls, stuff like that. Stuff that the aerospace industry will not use, but that it's actually perfectly good carbon fiber. I mean, they will not use it because of the rules of their
because
industry,
of the certification
not
requirements.
Just,
Which are different.
Exactly.
Okay. Romain, in CDK, what's coming and what will we see? I think for sure one element that we see in foiling that is happening is that the application is coming very fast in the motor use and in the commercial use of motor, let's say of ferries and foiling boats like that, but also in the general transportation of people. Is CDK involved in any of these projects with their composite capacity?
Yes, exactly. As I told you, we told before, the first carbon part made on sailing boats and commonly used was a mast. And now we are...
Just give us the size of what we are looking there.
So the size is 75 meters. We are doing some part of mast. So we are doing 3 masts actually. And for a cruising ship. So all the new equipment for the marine transport now have arrived because of all the R&D, research and development laboratory of the offshore racing and inshore racing race on what we have done many years ago. So that's happened due to all the foiling boats and racing boats we have done before. And other projects we are doing a new multi-hull team boat for Gitana team, a new concurrent for Tom, and other lot of projects.
Of course. Well, Tom, you SVR is let's say part of the Merconcept world, right? And the trickle down of the technology that comes from the team flows into the company and its ability to generate ideas that are then used in the rest of the nautical industry? What is your idea of how this technology, whether it's the composite or the foils, can benefit the rest of the nautical industry from what you see happening at MER or even in general? What kind of projects are coming that will see benefit from these applications?
But the foil and the composite materials are the advantage of this technology are evident, I think. The challenge we have to face is the environmental footprints and also the cost to integrate all these technological and advanced materials in the sailing industry, most popular and largely. But I'm sure, and we think that in the next years and next decades, it will the advantage of those technology will easily balance those challenge. And just we have to remind that tomorrow, with this kind of technology, we will be able to go at the same speed as today, but with less energy. So that's one of the things to remind you those foils and or composite materials. And yes, today I find this research around all this project research, the innovation, are really interesting and fascinating. We push boundaries and we don't know how it will be in few years, in 10 days or 20 days. To know how it will be for foiling boats and all the maritime world, we don't know. It's very, very interesting and exciting. And now my job is today is to steer this boat, but we also have a maritime mobility department in MER Concept, and the goal is to put some innovation of the racing and some racing, yes, the innovation of the racing department in the world of the maritime landscape. Yeah, we have some how we say,
the Vela projects.
Yes, we have some real project coming, and we already have an electrical catamaran foiling, and we work on vessel with hydrofoils for transport. The Vela project, which is a sailing ship, which is the goal is to cross between North America and Europe by the wind forces and to transport some many things.
It's a cargo ship.
It's a cargo ship, yes, it is.
So I think it's funny that if 100 years ago somebody was saying that the next new thing would be to go back to sailing cargo ships in the 2000s, and that this is working and it's saving CO2 emission, I think it's amazing that we are going back there, and it's very interesting and challenging for the nautical industry as a whole.
Yeah, it's really challenging today because it's a new we go back, but it's a new concept with this size of boats and many things to integrate it and to have, but fascinating. And
which is what we see also in foils at the end of the day. It's a very old technology that we are kind of reinventing because the technology has matured to a level that we couldn't even fathom a few years ago. And what I think is what is interesting of this industry is that the speed of development in the industries and of the performance that we achieve is incredible. Like I can see my personal experience. I sail moths, which are the tiny little boats. When I started in 2007, we were doing 14, 15 knots upwind. And now with the same boat, we do 20. So that's a 50% gain over 15 years. If you take a normal boat like a 470, that is now a 40-year-old boat, probably the improvement of speed is probably been 1 knot over these 40 years. The America's Cup boats, in the previous cycle, they were doing 50-something, and now we know that the new designs are probably going more in the 60 range, going in super cavitation modes. But then the difficulty will be Fabio, how do we, is there a way to compensate for this extra speed, trying to lower the emissions? Can we do speed and sustainability at the same time? Are we looking into materials that can substitute, let's say carbon fiber, but can we make carbon fiber more carbon neutral? Or can we use different composites to achieve the same, let's say, the same technical specs that carbon fiber reaches today? Or maybe it's just a new way of building, not just a new way of materials. It's a combination of things. What is your opinion on this?
That's correct. So that's an interesting question. Sustainability or carbon neutral is it's a bit complicated answer in one shot. There are definitely multiple directions to go. One is introducing new materials, or because we are in advanced composite material conference, thermoplastic. I'm a big fan of thermoplastic materials, and they can probably overcome some of the limits. I mentioned before, delamination is one of the major quality of a thermoplastic material. They have the tendency to be tougher than a thermoset material, especially for impact or events that it's something real for a foil concept. Thermoplastic is also more sustainable versus the thermoset material. There are a few other aspects, like, for example, considering the end of life. So right now, the market, it's relatively small, but tomorrow we will have many foils. They have to be replaced, like tires, right? So tires industry is sustainable if you can recycle or you consider end of life. So that's an extremely important phase of thinking. So PepsiCo cannot not consider the end of life. At a certain point, we need to consider what's going to happen. That be sustainable, that is a large meaning. So processes and the way how you consume energy when you manufacture, the new material, like I mentioned, thermoplastic is one of the directions to go. Automotive is a practical example. But definitely reinventing or evaluating this market for sustainability require all of these aspects all together. We need to see the big picture. It's not only a single material solution that can allow to be sustainable. Choosing correct the supply chain. Supply chain is part of that. So we need to know about material mix, how they produce the material. They are sustainable. So be sustainable is not only a problem for a single company, but is the entire full at the end of life, like I mentioned.
That's why the industry is finally starting to use life cycle assessment tools to understand that one thing is, okay, production of the material, and another is the whole life cycle use.
Correct.
How you can reuse, recycle at the end of life what you have made. And that's what's making a difference. And for the marine industry, that's kind of new.
It's new. It's new.
But I would say that especially the foiling side or the racing side are kind of the forefront of learning how to use these tools. At the end, the curiosity that we have as
absolutely
people passionate about technology goes also into how can we use this knowledge to limit, if possible, CO2 emissions when we build our racing machines.
If we want to add some conversation around the marine industry produce gigantic molds, and we need to find a way to, you cannot have and collecting these gigantic molds. So what's going to happen? How you can separate the glass fiber to the wood, for example, that you have, and then so all of this conversation in be sustainable. It's at this point, in this moment of the level of technology we see around us, we need to establish partnership with companies that can help, that is not possible to do only internally, in my opinion. So I'm a big believer of working together instead of considering ourselves an isolated, wonderful place.
You would need a falling organization to put all the people together.
Compliments. Look at that's exactly what you did, right? And you do, right?
We didn't plan this.
No. That's a very good idea, and I believe this is a practical example where we can sit down together. I mean, thank you, Luca, for creating this network. I personally believe that your contribution in this environment we are at the beginning, but I hope all of us here we can help you, and not only with nice words and a 40 minutes speech, but the commitment and the consistency on this topic should be. So that means that we're going to have another invite from you for another.
Well, let's see. We have in theory 40 seconds, but maybe no. That's the next one. Maybe we have time for a quick question for anyone. If there is anyone that wants to ask questions, I cannot see too much. Oh, wow. Anyone with any question for the team here?
Thank you. Hi, Louis Motion from We3D. Fabio, I appreciate you mentioning the importance that thermoplastics is having in your vision. I'd like to hear from the other panelists, what resistance do you see to moving away from thermosets to more thermoplastic and more sustainable materials throughout the industry?
So in my opinion, it's absolutely possible to design lowering the stiffness. So if stiffness is, for example, a performance that could be critical for the thermoplastic, we are okay with that. The complication for the thermoplastic is the manufacturing process, because it's pretty unique and special. So it seemed to me today we have like a boutique of a foil, right? Every design, every program, it's unique and special. Thermoplastic require more like some standard mindset, and that is the limit I see today. But this is only a matter of time. I think is a necessity to move on the thermoplastic. That's my personal opinion. Maybe someone can disagree, but yeah.
David, maybe you want to add something as a designer point of view to this?
Well, no, I agree completely. The thing is, in our industry, we have there are two sides. There's one side where things are mass-produced or at least series-produced, and thermoplastics apply very well to that, absolutely. And we are here a few people who make one part of each. And the whole, the heat, the molds that can hold the heat and so on are, well, it's a question of money. Making just one part out of thermoplastics is usually much more expensive than thermosets. Yeah. It's quite as simple as that.
Agree.
Any other question? Anyone? Yeah.
Thank you. This revolution in sailing has multiplied by 4 the speed of boats, and with that it had provoked some new constraints and new issues. I think that Tom unfortunately had to stop his amazing starting race because he hit something in the water, and it is certainly something that goes with the speed. I mean, the fact that it has broken the hull comes with the strength of the shock, but that means that those boats are going so fast now that it opens a new question about how can you see further and further because you go so fast. So is that going to be a question answered soon? And is it a way to make sure that those boats are going to be sustainable also in terms of reliability at sea? Because the problem of this speed goes with all the non-identified object that floats all around. So what's your point on that, Tom?
Well, I'll take it at the beginning a little bit. We just had a discussion on this before coming on stage. I think at the moment this is the main topic that we have to face as industry, which is relative not only, of course, to the racing yachts that Tom is using, but also if we are developing motorboats like Candela or anyone else in that sector, or even commercial ferries that are foiling, we need to be able to see ahead and to act so that we avoid whether it's a fauna or it's an object or whatever. As foiling organization, we are launching an initiative. We have a congress in a month, and the idea is to do an open source research that goes and look into this by putting together everyone in the industry sharing the IPs. And I think this is the right way because it is important for the industry as a whole. It's not just one company or the mockers or their teams. It's the most important need that we have at the moment. On one side, there is, of course, the, let's say, the conservation of fauna, which is a very important topic on one side, but also there is a very practical need that if Tom was able to finish the race by not hitting something, he would certainly be a happier sailor, right?
Yes, of course, I hope we will answer this question soon, but we were discussing this before this meeting, and the exact technology and the exact sensors to put on our boat to evitate this kind of injury issues is not very clear today in which direction to go, but we start working on this subject.
Yeah, there's companies that are already working on this environment, but I think the technology is kind of out there. Probably a little bit of it is in the military, but they have different budgets. We need to make it a commercial, available, off-the-shelf system that probably needs to integrate not just underwater sensors, but above water sensors, artificial intelligence to read through the waves, which is probably one of the most difficult part. To see forward and say, okay, that's a wave and that's a whale. It's two different things. And if you need to look like Tom that goes at 40 knots, that's 20 meters a second, you need to look at 400 meters before you if you need to see sufficiently ahead to act and do something. So it's a tricky one, but I think by putting all together the system, we can find a solution pretty soon. Anyone else has something to add? No? Okay. I hope I answered your question. I'm not sure if we still have time, but if they don't kill me, I keep going. So anyone else has questions?
Hello. I'm a sailor on the Mini 650 circuit, and we have a new boat with mineral specific materials. And my question is, do you think we could add, because the sailing is driving the innovation in this sector, and maybe adding, coefficient to the races with the coefficient of sustainability of the boats could be interesting to, optimize the boats for sustainability and driving the innovation to sustainability and not only speed. What do you think about this proposition of adding like we do in Osiris or IRC, which works really well, maybe adding something like that into offshore sailing?
Well, for sure, David will know there are races that have in the, let's say, notice of race participation that the boat must have a minimum recycled material. Even the America's Cup has a number of like 10% of the boat must be from recycled systems and stuff like that. Yeah. You're probably more familiar than I am. Just quickly, David, on one thing. Behind you, there is a team that works. They are from Italy. They do an initiative that we launched, which is for universities to design, build, and race a sustainable foiling moth. And that's exactly answering to that. It's trying to see if we can merge performance and sustainability and bring it to the industry. So there are initiatives out there. It takes time, of course, for these students to become, to work for Finoconc and change the industry from within.
No, I think the sailing, the competitive sailing world is very aware of that. It's, and the things are changing at the moment. For example, the IMOCA class is working on writing the rule for the next cycle that will limit the carbon emissions, well, the equivalent carbon emissions of a boat. So it's something that is being taken more and more into account, most definitely. Of course, the boat is not the only source of emissions in our sport, like in every sport, actually. But it has to be taken into account, and I totally agree with that.
Anyone else want to add on this? Any other question from the public? No? Okay, well, David, Romain, Tom, Fabio, I was saying Federico, I don't know why. Thank you. Thank you for coming here, and thank you everyone for listening to the
Thank you, Luca.
speech.
Is the mic on? Mic on. Thank you, Luca. Thank you, everything. We just witnessed that these gentlemen were talking about sharing experience, even in a race for competitiveness, and that's what we've been wanting to do today. Even though we're working in a specific field, it's about sharing emotions and experience, sharing emotions that push to actions. I've had a blast researching and experiencing and communicating with you, with those movers and shakers. Our world is going at a frenzy rate right now. We can all do baby steps in terms of sustainability to make it better for the next gen. Have a great deserved lunch, and we hope to see you next year. Thank you very much.